concentrate everything related to the AI in the company and provide AI to all the other servers and the other products instead of having to add external keys to every place. And the idea of the playground for now is to have models of text generation, speech to text, and text to speech. So we can choose whatever model we want to work in terms of LLM, and we can choose the modules for speech to text and text to speech. For speech to text, I'm going to use Whisper, and for text to speech, now I can use Azure. But we can instance, if we want, different models on the system. So we can start, let's say, a model like OpenChat, or different models like Llama or Dolphin or Veles, or other models on GPUs, local GPUs or GPUs in the cloud. So that's the whole idea of the system, is to have inference. Another thing that we have created here is the concept of agents, where you can talk to the agent by chat or by voice. So what I'm going to demonstrate today is the chat by voice. I'll do the chat by a chat, and then by the agent by chat and the agent by email, to show some of the things that can be done using LLMs. To show you, I have a SIP server here. I have an API server in the cloud here. This is where I get the flight information. I get the flight information from Amadeus, that it's a cloud service, but Amadeus has a little problem. You have to renew the tokens. So I wasn't able to connect directly to the Amadeus service, so I had to create an API in the middle just for authentication. And you don't need to see this. But yesterday when I was showing you, I had forgotten to start the Amadeus in the middle. So what's the idea? You can ask about any flight information, and the system will answer you the flight information. I created another very simple one. That is the Receptionist, something that most of you are familiar. Let's just start with it. I'll do the Receptionist on the playground. So let's start. Let me get the agent. So on the agent, I just programmed something like Flavio is in 1000, John is in 1001, China is in 1002, sales in 1001, finance in 1002, and technical support is in 1000. Okay. Let's see what we can do with this.
Я пока что фотку поставил, я пока разбираюсь. It's capable to understand the context of the call and to transfer correctly. It doesn't matter what microphone you tell. So it doesn't matter what you're telling, it's transferring the call. So this is connected to our IVR, and then it transfers the call to the right person, but using natural language directly. The second one, we are going to use an API.
playground. I have given her some instructions. So you must not chat about any other topic. This is a question, yes. To the LLM. So let's try to fuck the system. Start with so it starts a conversation, certainly. I have to assist you with flight information. What details you need? If you want to give your own flight, it's your label. So. I'm not passing all the information. The API has three parameters. The flight code, the flight number, and the departure date. So it's all of that. You don't have all the information. Please give me the information about the so completely informal. And now, let's move on to this. Now I have a phone, I will call SIGBox. SIGBox is local machine. SIGBox is so it's information 7. Answer the call and it will start. information about the flight LX93. Yes, please. May 16, 2024. Yes, May 16, 2024. Sure. Flight LX93, May 16, 2024.
Изображение не обновляет оно его вовремя. Не тянет, как ты говоришь.
Okay, thank you. Okay, thank you.
А что повисло-то непонятно?
Thank you.
Включить можно.
Нормально.
Он затормаживает весь процесс.
Ну, он все равно должен сказать, что 7% только CPU заняты.
Okay. Sorry,
Скорее
there's
всего,
still
драйвер
in the bot.
может
Actually,
перезагрузить его.
there's still some things to do in terms of let's say the
OBS может
voice
закрыть и
activity
открыть.
detection. But in MRCP, where voice activity detection is already a lot more developed. It works much better. I just wanted to show the bot because the bot is so simple. You can connect to any company. And as everything that we are seeing in AI, this is probably the worst you can see now because it's going to evolve very, very quickly in the next years. So this is what we are working on. We are working on AI models, open source and closed source. This doesn't matter. You can choose if you want to use Microsoft or if you want to run your own model and add to the users because we had, as I have shown you yesterday, several problems that we have to address and several opportunities that we have as a company. So we, in the future, in terms of telephony, there's a lot to do in terms of customer service to get to the users and on customer service. And there's a lot to do in terms of selling inference to the users. Because what's going to happen? You can do this with OpenAI. Actually here it's OpenAI, Whisper, and Azure. It's slow because the servers are very far from here and we have a lot of latency on the internet here. But it's much faster. If you have something like a local TTS or a local ASR, it's even faster. And I'll show you next the ASR running locally, and you can run. So the first part of the demo, and I can share with you the Colab. How many of you know the Google Colab platform? Have used it before? Very few. What's Google Colab? In Google Colab, you can use what we call Jupyter Notebooks. Jupyter Notebooks is a very interesting way to run Python. So you can run Python code in a page. So it's very, very easy to share code with instructions, with everything. And here we can assign GPUs. It's hard to read here, but this is a T4 GPU, and I can run this GPU, and it's not expensive. It's very, very nice for testing. So most of the things on AI are shared on Jupyter Notebooks. And in these Jupyter Notebooks, I have created an ASR inference. So what is this? We have some models, in this case from NVIDIA. These are open source models. These are models for ASR. And here I have loaded two different models. The one that has the highest accuracy in terms of open source ASR. Lots of surprises.
Oh.
And so I'm loading the Canary model, and this is the most accurate open source model. And I'm loading the fast conformer, that is the fastest model in terms of ASR and open source ASR. So going back, so this is still loading. It takes time to load because if you look at the GPUs here, you will see that my GPU is starting to load. So it's in 0.6 from 15 gigs of GPU RAM. So these models are being loaded on the GPU RAM of the system, right? So it takes time. It does not take time to the inference because you load the model once, so it's not going to happen all the time. So you start your server, it will take maybe 10 minutes or 15 minutes. If you have an LLM with 156 gigs, it takes sometimes half an hour to load. Right? If you're running something like a Gamma 7B, it will take 20 to 30 minutes to load, just to load. So it's loading. Great. Still loading. Loaded two models, the Canary and the fast conformer. So I think the first one had loaded and the other one's not. And I can't run the next cell until the first one. Actually, I can scale it. Just a second. It will open for me a report. And in the report, we can report whatever you want to record. Any suggestions on what to record? Let's do the obvious. The quick brown fox jumped over the lazy dog. The quick brown fox jumped over the lazy dog. Even this works even with a poor English. So I have converted to file.wave. So I'll start with the Canary. Start time, predicted text. That's it. Just doing the inference. Usually the first time it does the inference, it takes some time, 4.62. But even if you change the file, if you run the second time, first time the model is run, it takes 1 second to translate. Right? This is the most accurate. The Canary, it's a bigger model. Now you can see that the GPU is on 5 gigs, so this model has 4 gigs of memory. The other model has 100 megabytes of data. Great, so now let's do the inference and fast conformer. said, first time it's always a little more. Okay. And the phrase is here. It's so the big brown fox jumped over the glazed dot. It's here in 23 seconds. It took a lot of time. And the big brown fox went over the glazed dot with punctuation. I have also asked it for punctuation. So it took 23 seconds in the first time. It's not caching, right? It's just the first time the model runs, it's slow. 0.12 seconds. Right, so you can have an inference model that is much faster. So the problem of the models is which model serves for us? The fastest or the most accurate? For a chatbot, sometimes maybe the fastest makes a lot more sense than the others. Right? For TTS, there are at least 8 characteristics of a text-to-speech to choose a model. Right? Let's say you may need a model with accents. You may need a model with voice cloning. Your user wants to have their own voice on the bot. You need to have a TTS that it's very fast. You may need TTS for movies have things like lofts and bars and other stuff. So there are many different types of TTSs to run. And actually the secret is to find these models, to run them on your own inference server, right? And then provide to all the systems you have on the and have also something like this that it's very important also, that is, let's say, I know exactly how many tokens I have spent on the interaction. So I know what exactly to expect in terms of cost of any interaction with the customer. So here is in the AIs. This one was not very expensive because it was created using a model called Claude High-throughput. That is the small module for Claude Anthropic. But if I put this in GPT-4, the costs are a little higher. And one interesting thing here is I can change the model without changing the agent interface, because OpenAI has its own agent interface. Anthropic has its own agent interface. Here we have the same agent interface for all the LLM models. That's the whole idea. Let's move to the TTS. I will disconnect this one. I will start with the questions now because it takes time to run all the dependencies and load the modules. And I couldn't do it before. I'll wait for the questions because it takes some time to load. At the end, I'll give you a QR code and you can download this Jupyter notebooks and you can try and No, they are not in the production. These are notebooks for development. For the productions, they have to go to an inference server. There are many of those inference servers that we can use as a basis, like Triton or C-Translate or DGI, VLIM. There are many. So we use one for the LLMs and another for ASR TTS. So for production, you have to take these models. For production, there's a lot of work still to do, because for production, usually we have to do quantization and reduce the size of the model, right? Let's say in Llama is trained is floating point 32. It's really big. But if you reduce the model to integer 8, so you can reduce the size of the model and run much, much faster on the inference servers with a low, the quality decays a little bit, decreases a little bit, but you can run much faster. So it takes, we have one person just doing the inference servers and getting the models from open source to get to the inference stage. And I think Max is doing the same in inference. You have to go over the inference server.
Это гениально просто.
There's a lot of work to do in terms
Есть захваты видео, а есть
putting the
устаревшие.
models in production, putting in
Устаревший, он
a
эту
Docker
камеру как
server,
раз таки увидит.
able to run in an inference server,
Вот, здесь
start
она есть.
in the,
А в стандартных ее не
start and
видно.
start the model and charge the
Какие-то
model by hour.
коды
That's the idea.
я
Let's say,
знаю.
if you have to transcribe, let's say, a whole call center, and you put this in OpenAI Whisper, the cost will be very high. So it makes sense to stop paying per consumption and start paying per hour. So start your own let's say ASR server, right? And go there and consume from your own server. You can, let's say, schedule to 7 p.m. You don't have more people on the contact center. You stop the server and stop paying, right? And if you have several servers, you can use spot instances and have a load balancer send it to them. And there are many ways to do it. In the costs, we used to see a lot of cost on the LLMs, but there's a lot of cost on the ESR. Whisper is actually very expensive. It's the most expensive part of the box right now. There's something to do, but there's a lot of work to do in terms of the inference servers. Find the inference servers, test the inference servers. We are having a hard time also because there's almost nothing in Portuguese. And so we have to train our own models, we have to create our own data sets, we have to do a lot of work. Because all the good Portuguese data sets are proprietary. There is no Portuguese is considered a low resource language. You cannot, there are some models that are not available for us. Let's say, there are models that you need 64,000 hours, not 64,000, maybe 10,000 hours of voice to train. There are models that you can train in 24 hours. Use 24 hours of voice. You can train Portuguese on this type of model. But the models, the large models with 60,000 hours, we don't have data sets for this, at least not now. It takes time, mainly when you're installing. It takes some time. Sorry. We have time. Go ahead.
While we wait, I wanted to know your opinion about what do you think like the general public will think about it? Because like when I call to a call center, I usually prefer to talk with a real agent. I don't know if users get frustrated when someone answers the call and they realize that it's not a real agent, that it's a bot.
Oh, I like this question.
Which is your opinion about that?
My opinion is all the bots from 2023 it will restart session just because it has installed it, so it has to restart session to run the next one. Let's see. But let me give you the answer to this is just load the models and I think what we want is to have our problem solved. Right? So if I go to a chatbot and I ask, cancel my flight, and if it cancels, I got surprised, yes, it cancels very quickly because it's very difficult to cancel anything on these days. So if the robot is good enough to solve the problem, people will love it. But if the robot is in a stage that, okay, I ask him to give an answer, and people will then say, human, please. Right? The success of the robot is to be useful to the user to the point that it's better than you, right? And I can say that from 2023 to 22 behind, the way we developed robots, we used to develop robots using flow and NASA, right? Was these are the phrases, these are the intentions, these are the slots, these are the, we had a lot of definitions, and it was very painful to a robot in the whole system. Now you're using LLMs, no XML, no intention, description, no slots, programming, nothing. It's much easier than it was before, and it's much more fluid. Have you seen that? Say, I want to talk about my payment. And it's still, no, this is fine. It's okay. He understands what you're saying. It's completely different than the bots that we had 2 years ago.
So, looking at the future of how these things are going to be developing, one of the things that's kind of obvious at the moment is that we've got two distinct components to let's speak to ASI, the AI side. So now we've got multimodal AIs, so we're going to probably start seeing these capabilities sort of design and potentially be able to interact with the AI directly through the speech and the back. Have you got any insights on how any of that is working? Maybe possible things like that might be out?
OpenAI launched a model on Monday, and they launched an interface for Windows, for browser, and for everything that you can do. You can talk with the AI. Conversation that it's not only one text to speech to text. Even voice activity detection used to be a lot better than it is. I think the ones on William ICP, the ones we did on research are working a lot better than this one. But there's a lot of work to do on this side. Create a good conversation, that it's not, there's more natural, where someone can interrupt, let's say, starts to talk all the information, I got information, okay, stop. To go next. So we're just at the beginning of this.
Thank you. I have a question about how the speech bot works here. I mean, on the speech to text part. Normally, I mean, you have two methods. You record the file as a wave or something central or system, and then get the stream for a stream.
You can stream.
So for the current scenario, you are streaming, and how do you detect the conversation is finished? Is it a silence detection, or is it something that is done on the device already?
For now, it's silence detection.
Okay. And one other question is that is it, I mean, when the AI wants to convert or when it wants to decide, usually we can make what we call it a thinking sound, like hum. Is this possible here as well in this report?
Everything is possible, but it's not there. As I said, there's a lot in terms of improving the conversation side of the system. But let's say people are already starting to use. We have customers using for the manuals. They put all the manuals on the system, and when their technician call, they ask information about the optical network units, which goes to the manuals and give all the information to the feedback. So we use a large number of people on the until you really get the voice and chat at some place. So whatever we can solve without using artificial intelligence, it's also interesting because it consumes a lot of resources before that. Right? So you can add all the boxes to have this idea. Okay, so now it's running. I have loaded. And here I can pick and choose the type of inference that I want. So there are several models here from NVIDIA and Spanish and English, Deutsch. What do you want? Spanish, English, no Portuguese. I will choose a mix of spectrogram generators and voice coders. Okay. Let's load the model. Same thing, it's loading the models on the GPU. That's it. The good thing is we only need to do this piece. The idea here is to show you the speed of this model. So you're going to see that sometimes people say, no, you can only do this on the cloud because we are very intensive. This is a very small GPU to film. And I can give you the inference time from the cloud model, so you can see the inference time on doing on your own GPU, and you see that it's quite, it's here. Nice. So now this loaded. If you look here, you see that these TTS models are not big. They are 0.6. Great. Now we have. Please hold while I transfer you to a customer service representative. The sample height is 22. Generate the audio. Okay. Audio generated in 2 seconds.
Hold while I transfer you to a customer service representative.
0.06 seconds. Let me do something. Because this can be caching. 0.12 seconds.
Hold while I transfer you to a customer service agent.
Right? So this is BTS. I think the quality of the voice is nice. 0.12 seconds.
What's best of the inference of the models and properties? What you get is from Veles, 224, 41, 69.
I haven't heard it. So you can see the models on 300 milliseconds within 130 milliseconds, 120 milliseconds. In a very shitty GPU. Well, that's what I had to show. You want to download the books and play. There's a directory on Google Drive. It's a way to share things. Huh? Have some fun. idea to handle this is you need to have a router in the beginning. What exactly you want to do? Send to. You can create an agent that can do everything. I could put more APIs in the same agent. Right? The problem with this is, let's say, you start to overload the agent, then you run the risk of having, say, you got confused about which API to call. But I think it's a better idea to route to specialized agents. But if you look at Amadeus, you have all the APIs to get luggage information, and you can upload files also for the company policies, and they will answer according to the company policies. So what really needs to be done, it's the hardest part. We have some people working on this, is to improve the conversational experience in voice. On chat, you can do it right, you can do it right. But on voice, it's the next time. I would say that in the MRCP, there is a good, say, voice activity detection working there. You have barging, you have some resources that you can use. But in the bot, it's still an early work. The idea of the bot was to create a solution for OpenSIPS because we don't have really MRCP drivers for OpenSIPS. Right? So we needed something really simple, like a client, like a user itself. But this thing is good about it. Yeah, because the good idea of the SIP bot is you can run whatever the customer has. You can put in any DBX, any system. It works. But, let's see, enough of work is a cause of fun. Sorry, speak a little louder.
I'm just trying to know more about
I'm just wondering about some more technical details about how you communicate with the data in server from this support. Is it sort of anything or? It's what's WebSocket too. So you can choose. The bot right now.
We have like roughly 10 minutes before next session, okay?
then it makes it like a lot of
Is that individual?
which is like dependencies of the maybe you can tell like about like the signal by your previous program.
So it's to me it's about business model. Business model.
Okay, so good morning, everyone. Let's go with the second demo of the day, and what I will try to show here, so basically to do together, is to implement using only OpenSIPS scripting. A simple service, typical class 5 service, the call pickup. First, just to be sure that we know what we are talking in terms of service. Do you know exactly what call pickup is in terms of the telephony service? So just in case, I put here a short slide just to describe first of all, again from the, let's say, user experience, what exactly this call pickup is, and next try to look at it from the SIP perspective. And then we're gonna actually do scripting for OpenSIPS to implement the service, and hopefully at the end with the work we're gonna give it a try. So well, what is the call pickup? Everything starts with a regular call, like Alice calls Bob. Bob's phone is ringing. I don't know, Bob has an emergency, had something bad in the morning for breakfast and it's in the toilet, so not able to pick up. And Charlie, somewhere like 3 desks away from Bob's desk, and said, wow, okay, that's the customer with the 1 million deal. So we need to pick up, we need to answer to that call, we don't want to lose the business, the deal, sorry. So, okay, how can basically Charlie grab that incoming call of Bob without being a Superman and fly over like 3 or 4 desks across? So, well, that's how, that's the need for this kind of a call pickup. Basically from his phone, Charlie will dial. Typically it's either star codes, kind of a service. Things may be a bit more complicated here. I will just give you an idea, but the idea is Charlie is dialing saying, okay, I want to grab this incoming call. And the effect of Charlie dialing would be the call to Bob extension or Bob's phone will be cancelled, and and we will have basically Charlie answering the call which was originally designated for Bob, of course completely transparent to Alice, so basically without nothing noticeable on that side. Now, how typically the call pickup works as a service, more or less it's about, okay, how Charlie is able to, you know, say, okay, which call I want to answer, because that's a simple example when we have only one incoming call. But imagine that, okay, you have some corporate environment with multiple departments, multiple incoming calls. The question, okay, which one do I pick up? So from this perspective, okay, it's somehow outside the scope of the demo here, but as an idea, it's just logic, or let's say permissions in how the service works. Usually you have like either pickup groups. So you have like, okay, I have the financial department, so when I do a pickup, so I'm calling to the service, to the pickup service, I'm just picking up any incoming call for my department, so inside the group, right? So it's structured in that way. Or you can do like, instead of simply dialing like, you know, service number, you can also attach dialing service number plus the extension, let's say, of Bob, saying, okay, I want to grab the call from Bob. But again, that's something like, okay, how you implement the logic. And of course, it's not only, think of this, not only like, okay, how do I specify which call? It's also about permissions, right? Because maybe I'm just, I don't know, the plumber in the building, and I don't want to pick up calls, try to pick up calls from the CEO in the building, right? That's, again, matter of permissions and privacy. So you have to think about from both perspectives. But what we are looking at right now is how to perform this from SIP's perspective. That was just some additional information in, you know, in the context of this service. Right. So let's see exactly what's the typical SIP behind it. So the magic. What's the magic behind it? Now it was being said that you know, as usual, there are multiple ways to skin the cat. So also for the call pickup, there are basically two ways of doing it with SIP. One, you can let the actual phone do the whole thing, I mean the end device. And this is based on the BLF support. So basically the BLF, it's present support, and the phones may see the calls ongoing between users. So basically in our case, Charlie's phone would be aware in terms of SIP properties like call ID, tags, and so on, to be aware of the call reaching Bob. So basically Charlie has all this information, the phone of Charlie, so it can implement directly into the phone the whole pickup story. Again, based on the BLF. So the proxy is just a simple proxy from this perspective, or you can actually put the logic of implementing and controlling the whole pickup into the proxy. Of course, we can look at this from two perspectives. Okay, which one is better, or advantages versus disadvantages. If you let the phone doing it, you say, yeah, okay, from the service provider perspective, or from the, let's say, service itself perspective, it's simpler. You know, you just distribute the whole load in terms of doing it on the actual phones, but the disadvantage is you will be constrained to use certain types of phones able to do that, and you'll actually rely on the phones to implement the pickup in terms of permissions and everything exactly as you want. So it would be, let's say, difficult to try to present the same kind of experience with the service to the users, considering that, okay, they might be using different kind of phones. So the advantage of doing it into the proxy is, okay, you leverage this, it works the same as you want for everybody in the system. So we will definitely look into this approach, like how you can implement this with OpenSIPS. So now let's see what are the typical call flows for such an pickup. So okay, we have, you know, typical invite, first call from Alice to Bob. We have the ringing. Of course, there'll be the 180 going back to Alice, and a completely different call, again from SIP perspective, from Charlie sent a call to the proxy. The proxy will be the one, let's say, implementing a logic. Hey, okay, that's a pickup. Let me see. Okay, which call I have to actually to bridge, and one figuring out that actually Charlie, I mean, the red call is trying to do a pickup on the green one. This ongoing branch here of the call, of the original call, will be cancelled from the proxy. So it's not Alice doing this, it's the proxy cancelling the call to Bob. So basically that's okay, it stops ringing, I'm done. And the proxy will generate a new branch of the same call from Alice to Charlie with replaces header, where this replaces actually points to the call, to the red one. So basically it's taking the call from Alex and it's trying to inject it to Charlie on top of the red one. So basically from Charlie perspective, it's like, okay, I made a call, but on that outgoing call, I actually connect with Alex. So from the user perspective, it's basically the same call. Of course, the phone would be performing transparently the replacement between the two. So this, the red one, so the call actually triggering the pickup will disappear, being replaced with a new branch for the green one. So that's the magic again from the SIP perspective of doing the pickup and having Charlie actually answering the call from Alice. So yeah, let's see exactly now how to do all this magic with OpenSIPS. And yeah, before proceeding, just to be sure that we have everything ready. Well, in the console here, there will be an running OpenSIPS. It's not so, let's say, important for you to see the logs. I mean, we can do the font larger, but you know, it's just to see it's running. It's completely irrelevant from this point of view, the logs. Important is to see the script. Let me know if you want the font larger. It's okay for you?
Larger.
On the console.
No, I mean the console again, it's not okay. It's irrelevant. We just want to see that it works. That's okay. We can try larger. Let's see. Okay. So okay, if we are in the script, I took basically more or less what you have, like that default config file that comes with OpenSIPS, which allows phones to register. We don't care about the authentication and so on right now. It's focusing, keeping things simpler, and focusing on the actual pickup. So basically, this initial script just gives your phones to the phones the possibility to register and make calls between. No magic, no nothing else. So we have, if we look, okay, we have the possibility here to register, and based on the lookup, just to do calls between. So it's a very, very simple script, and we will add some blocks in there which are relevant for the call pickup scenario. So going back to the slide, what's the first step to do? We have the incoming call from Alice going to Bob, and what we want to do is, let's say, to prepare somehow the call to be eventually, if this is the case, picked up. So for this correlation between the two calls, like, okay, I have a call from Alice to Bob, and later, you don't know exactly when, or even if will be such a pickup call. So the second call from Charlie. How we correlate these two calls, it's using the event routing support in OpenSIPS, where you can wait for, you can wait to be notified for different events, and in different parts of the script, for other calls, you can raise some events in order to pass basically information between calls. So what we want to do is, for this initial call, so the call from Alice to Bob, I just want to, I'm setting a route to be executed, this bridge pickup route to be executed whenever, if there will be a call pickup event. So basically, I'm just setting kind of a triggering, and whenever there will be a pickup event triggered later, let's say by Charlie, I want to have this bridge pickup route executed, and the whole idea is to put the magic about pickup logic in that route over there. So again, is something pretty simple. It's just a hook saying, okay, for this call, if there will be a call pickup event, I want to have this route executed, to do some custom stuff over there. And this is done when handling this event, this invite from Alice to Bob. Definitely, if there will be no call pickup event raised whenever, let's say there is a ringing to Bob, it will be like any regular call, so there is no harm done. And probably most of the calls will simply ignore all this if, again, there is no such pickup event raised. We will not be using this, but let's say if you have more complex scenarios, you can use some filters in order to say, yeah, okay, this event is valid only, if this kind of a filter, meaning like value equal, a name equals some value, whatever you want to be, so it's up to you. So only when we have some key equal value happening. So it's just to control eventually if this event is applicable to us. In our case, we just do something simpler. We just grab all the events. It doesn't matter who's actually raising them. So let's go to the script. And as we said, that's the part before the lookup. So that's the place where we actually prepare the call to be sent, in our case, to Bob. And as we said, okay, when we do this, we want to set this potential triggering for the call pickup and have the things ready. So, okay, let's have this one over here. So I had, like in the example, the filter, and then the actual sorry, not tonight. Okay, so that's in terms of scripting, the first step. Let's say the call is prepared eventually to be picked up by such an event, and then again, whenever this event is raised, we will add later such a route which will contain the logic for picking up. So let's see exactly, logically speaking, what will happen next. We have so the call was finally sent to Bob. It's ringing. Nothing special we need to do for that. And then Charlie will dial let's say, the pickup call, so the second call, into the system. So in this case, first, based on the script, we need to identify, so let's say we dial *99 or whatever, just to say, okay, that's a pickup service. We need in the script to identify this kind of dialing to a star service. And then we need to raise that call pickup event, saying, hey, somebody's trying actually to do a pickup right now, in this case Charlie. And together with the event, we want to attach some information about the red call, so about, okay, who's doing the pickup, so basically Charlie, and information about the call, like, okay, what is the call ID, what are the tags, so some identifiers of the red call, so when the event would be actually delivered on the green call, on the original call, we know, or we have all the information about, okay, who is trying to pick up the call, Charlie, and okay, what are the attributes of the other call. So let's do this in the script. And as said, we have here, at this point, you see we have only invites, so whatever it's not an invite in the script, we are just declining. So again, we deal with only with the initial invite. So we can do something like, okay, if there is some call attempt to a non-user, to like a star service, so if I'm dialing *99, meaning, okay, I want to perform the pickup. In this case, what I need to do, I want to, first of all, deal with whatever is necessary for the current call. So in terms of proxy, I will just generate a reply back to Charlie. Okay, here's a small issue. Normally you could simply do like 180 ringing because, okay, we are not proxying, we are not sending anyone the call from Charlie. It's just an indication for the proxy itself, like, okay, that's a pickup service. But from SIP perspective, we need to send something back to Charlie for that call. Normally you can simply send the 180 and so to keep the call from Charlie in ringing in kind of an early mode and then to send that invite with replaces. But I would say that 60% of the phones do not support call replacement on ringing calls, on early calls. They are able to do replace only of established calls, right? That's a bit of a limitation in some of the phones. And just to be sure that we are covering this, we are pushing a bit the limits over here, and we make OpenSIPS actually to generate the 200 OK. I mean, to simulate that the call from Charlie is actually answered. Okay, of course, it's just in terms of signaling, just to make possible later the replace. So what we will do, we will simply send back for the call, for the pickup call, and we just generate an reply. I need to set the IP of this machine. Okay, and I'm just sending a 200 OK with some. I'm just to be a body. I'm just reflecting back the XDP we received. So this will simply send back a 200 OK. It will answer the call to Charlie, and so I'm done with the signaling. And then what I need to do is to actually generate that event to connect me to link me to the original call. So I will just do a copy paste to be sure that it's quite a bit of a text. Okay, so we had the signaling sending back the 200 OK to Charlie, and now basically I'm doing this, that's the most important, this raise event. I'm generating the call pickup event. So I'm letting the call from Alice to Bob know that, okay, somebody is attempting a call pickup. So that's, I'm raising the event, and to the event I'm attaching some keys. OpenSIPS allows you to attach any kind of a key value information you may need. And we have like two sets. That's one, key and value. So picker, so who's performing the picking is, and that's some information. I'm trying to format it as an like a parameter kind of value. So receiver is source IP and port, so just to know exactly where the call came from, and also what was the contact field of Charlie. Because why? Because I need to send that invite to the replace exactly to the same phone of Charlie. So I'm trying to remember where the call from Charlie came from. So I'm going to send that new call to exactly to the same, from network perspective, to the same origins. So I'm saving the source IP and port of the call from Charlie, and also the CPRI of Charlie. So I'm putting this into the event, and also the SIP information of the call. So that's another key value here defined. So I'm storing the call ID from tag and to tag, because I need to place that information later in the replace, in the invite plus replace. So I need this. So basically I'm collecting some information about, okay, who is the picker, Charlie, that first key, the picker, and also about the SIP properties of the call, doing the picking, so I can do the replacement. So I have this key value, and I'm passing them to raise event to this call pickup. This call pickup, it's exactly the same event, you see here, that the original call will be waiting for. So when this call pickup happens over here, basically OpenSIPS will start executing this bridge pickup route, which is not yet defined. We're going to define it. But the idea, that's the way we pass the information between the two calls. One is waiting for the event, and the other one is generating the event. Okay, so going back to the slide. Right, so we had the second call from Charlie. We detected it. We said, okay, if it's a *99, we do all the magic in terms of raising the event and putting all the information in there. Now, let's see what would happen. So in the context of the original call, which was waiting eventually to be notified, this bridge pickup route would be executed, right? That's the whole idea. We want to trigger some action into the original call in order to, let's say, implement the actual pickup logic. And what we will do over there basically is to cancel. We want to cancel this ongoing branch of the call and generate another one to pointing to Charlie. So to create a new branch for the original call, kind of imagine kind of a serial forking, if you want to say that, going to, in this case, to Charlie. So yeah, let's do that in the script. So again, I will do a copy of this bridge pickup. Let's put it here, and I will also explain exactly what it is. Okay, so we have this bridge pickup, which will be executed because of whenever this call pickup will be notified, and as parameters will automatically receive as AVPs whatever key values were attached when the event was raised. So this information will be passed and visible in the route triggered by the event. So you're going to have the AVP call and AVP picker with, again, holding exactly these values, right? So that's the way they correlate. So what we need to do in the so-called, pickup handling, well, the magic part, it's this de-inject branch. So basically, I'm going into the call, into this original call from Alice to Bob, and from the transaction perspective, so SIPS perspective, I'm injecting a new branch, so basically a new destination. I want to inject a new destination pointing to Charlie, right? And for that, I need to do a couple of things. I need, of course, to set a destination, so to say, okay, what's the request URI and eventually the destination URI for this new branch. So that's information that I'm taking, you see, from the picker AVP. I have the URI and the received. In the received, I was storing the source IP and port from network perspective. So I'm, in terms of where to send, I'm sending exactly to the same network coordinates. And in terms of request URI of this new branch, that's would be the context. So this URI and RCV are this one we put here. So RCV is source IP and port of Charlie, and URI is actually the contact which was advertised in the call coming from Charlie. So I'm trying again to go back exactly to the same point Charlie called from. Imagine that you may say, yeah, why do I simply do a lookup location, to find out where Charlie is located? But I think about Charlie may have like 3 or 4 phones registered, right? So I want to send the call you know, from Alice to the exact same device where Charlie dialed in order to perform the pickup. So I need to be strict on that. So that's why I'm storing the information into the event, and then we are using it like this. So yeah, I'm setting the destination that will be used by the tinject branch. The second parameter of this tinject branch says what to do with the existing branches, because right now, you know, Bob is still ringing so far, right? And when I inject a new branch into the call, saying, okay, I want to have the call sent also to Charlie, the question is, okay, I'm simply adding a new one, so resulting in two devices ringing, or if I put that cancel parameter, means whatever branch exists at that point will be canceled, and I will basically have only the newly injected one. So just this small parameter will take care of automatically canceling the branch to Bob. And what I still need to do is I need to add in this new branch invite sent to Charlie, I need to add that replaces header. So basically, from the user perspective, you will see that you know, Charlie will actually have the call, incoming call from Alice, overlapping on top of the call he just dialed out in order to do pickup. So from Charlie's perspective, will be like dialing the service and suddenly, you know, being connected with Alice. There will be no two separate calls. Again, from user perspective, from SIP's perspective, yes, there are two different calls, but again, it's a replacement. So from user perspective, it should be like, you know, the same, still the same call. So for that, just to show how to do, I want to add that replaces header when this new branch will be sent out, and I will use the on branch. So whenever the branch will actually go out from the transaction engine, I will have this possibility to add an header. Right now in this route, so basically in this route, I don't have access to the transaction, to the message. I'm just preparing, I'm just instructing, okay, you know, just create a new branch, that's it. So more or less, that's the only thing that I can do over here, is just to inject a new branch in terms of sending to a new destination. I cannot add here the header, because basically that outgoing invite doesn't exist yet. So I'm doing a small trick. You see, I'm taking all the information about the call to replace, this AVP call, which was defined here, this one, holding call ID from tag to tag, so all the coordinates. I'm taking them, and again, I'm just doing a trick. I'm placing them into the request URI, just to be able to see them later in the branch route, where I will have access to the message. So in the branch route, I will take them out from the request URI and move them into a replace header. So, okay, that's what we do into the pickup. Basically, inject a new branch. I want existing one to be cancelled. I'm setting as destination, okay, to go exactly where Charlie dialed from. And I'm attaching to the request URI also as parameters what's the call ID from tag to tag of Charlie's call. So we can add later the replaces, right? So let's have the branch route. We already have an how to say very simple. That's the default script. So you see, for all invites, the script is already setting a on branch, this per branch, which right now is just logging something. Okay, you know, there's a new branch going to with a certain URI. But in our case, we want to do a bit more, so we put here some more logic. And just to be sure that, you know, we want to do this only for the calls which are generated in this call pickup scenario, so not for all the calls, because this branch route here will be armed and executed, I mean triggered for all kind of calls. So we want to actually do whatever we need only for calls related to the pickup. So we are doing this kind of test to check if the in the request URI I have the pickup equals yes parameter, which was, you see, it was headed here. So I'm just placing a small, like a cookie, into the request URI to identify these branches which may need special treatment because of the call pickup. So whatever branch was generated here by the inject will have the pickup equals yes, and later when that branch will go out from OpenSIPS through the branch route, I'm able to test for it here. And then you see I'm doing a lot of text, let's say, manipulation to create this replaces header, where I'm placing the call ID, to tag, from tag. So I'm extracting from the parameters which were placed in the request URI, the call ID, to tag, and from tag, and then I'm just doing a cleanup. I'm just removing all these, you know, parameters I used as let's say trick inside the script to be sure that they are not sent out to the actual device. So I just use those parameters to carry some information between different routes into OpenSIPS, but I don't want to leave OpenSIPS. So I'm just removing them. So that was the pickup was the marker we used here, call ID from tag to tag, which were used in order to replace. So at this point, basically I also have the I'm able to create and properly route with the replace header the branch to Charlie. So we did this bridging with injecting cancelling, and as a result of that, as I said, as a result of that de-inject branch, the cancel was sent automatically. We will see later in a pickup, and the new branch was created towards Charlie. And here was this T-on branch where we will actually add the replaces, right? So we do the replaces into the invite going to Charlie. Now, when the user device of Charlie will receive this invite with replaces, the replaces pointing to the call with red. So we will have this new call saying, okay, I want to basically replace the existing call with these coordinates, again, the red one. So when the device receives this replaces, okay, so no problem, we're gonna replace from the audio perspective, so user experience, and it will terminate the red one, you know, it's replaced. So basically, Charlie will send a buy for the red call. And because you see, basically OpenSIPS acts as an endpoint here from the perspective of the red call. It's not proxying it anywhere. Well, it would be nice to, let's say, intercept that buy and send the 200 OK. You know, anyhow, that call, there was no audio, no nothing. It was just an indication that Charlie wants to perform an operation. So it's more or less like dummy just signaling. But as I said, it's nice to play fair all the way. So we will need to intercept again the buy and send a confirmation 200 OK for it. Where we do this in the script? Well, we have to go in the script where we handle the in dialog sequential request, because yeah, buy is such a request. And here, have this, okay, 2 tag, so it's a sequential. So we just add here some extra logic for sending the reply to the byte. So, and that's like we do for the cancels, for the ACK, sorry. And we just okay. So here I'm looking if it's a buy. If the request to username domain points to me, so basically I'm from the SIP perspective, I'm the last hop. So yeah, I'm the endpoint for the buy. And also I'm checking, you know, 100% sure if it has this URI parameter local equal yes. Probably it's one of these buys for the pickup, from a pickup scenario. So what I'm doing, sending a 200 OK and done, nothing special. This parameter local equal yes comes from the point where I am answering the call. Here, I'm when I have the pickup, I am answering, and in the contact, you see that I'm sending in the 200 OK, I have this local equal yes. So that contact information will be used later for sending the byte to OpenSIPS, so I can recognize that, okay, it's about such a call. You know, again, it's just a small trick to try to correlate things a bit. So, yeah, more or less that's that should be everything everything we need here for the call to handle the call pickup. Let's see. Yep. Trying to quickly recap a bit. So whenever I have a new call between users, so after I'm doing lookup, so I know the call it goes to a user, I do this kind of you know, setting, like I'm preparing to receive eventually a call pickup event if someone wants to pick up my call, and that's it. Then if someone dials *99, I'm saying, okay, that's a pickup. I'm answering the 200 OK the call, so just to have the call as established to make the phone happy. And then I'm raising the call event, this call pickup event. I'm attaching information about, okay, Charlie, what's the IP and URI of Charlie, and also about the call, like call ID from tag to tag. And this call pickup, whenever it's raised, will trigger the branch, bridge pickup route, this one here, which in the context of the original call from Alice to Bob will inject as a new destination, a new branch invite to Charlie, canceling whatever was before. So basically canceling the ongoing invite to Bob. And to be able to do the replace later in the branch route, the information about the call is stored in the request URI. So when I have this branch route here, I'm just creating the replace header in the invite going to Charlie. So hopefully there are no errors in the script.
There is a backtick.
What?
Backtick, if an event relay,
oh,
you have a backtick.
This one?
Yeah.
Yeah, we know how it is. You know, the hope dies last. So let's. I will start OpenSIPS like debug mode just to see, you know, the thing that. Okay, so it's running. Now I have a couple of devices, like 3 devices. So that's Bob. Let's for some registration. Okay. Okay, so now Bob it's registered that's Alice. It's a twinkle. So Alice basically will call Bob, and to take care of Charlie, I have on the mobile. I have another VoIP app here. Let me just force registration because OpenSIPS was stopped. Okay, that explains a lot why it's not registered. It's on the wrong Wi-Fi. Hold on. Just a switch. Okay, Charlie is also registered. So what will be the well? Okay, let's start SN grep so we can see exactly the signaling, the resulting signaling. Okay, so I think we should have everything prepared. So let's bring the devices in front. So again, Alice from here will call Bob, and then hopefully I will try to, from device here, dial *99, and I should get the call from Alice. Bob should be cancelled. There are a lot of should in this, right? So let's give it a try. So let's call Bob. Okay, we see it's ringing over here, and now doing boom. So you saw that in VoIP was cancelled, and now I have the line 1 established, and I have here like talking with Alice, the call. Unfortunately, Twinkle is not so friendly in showing like ongoing calls, but you see here it says line 1 established. No, it knows it called to Bob, but that's a different story. So, ending up the call now. So I close from Charlie, and the call was disconnected. And now we see we have 2 calls here. One is Alice to Bob, so that was the original call, and we can see that, okay, that's in the middle, it's OpenSIPS, that's on the left we have Alice and Bob. So we had the invite going to Alice over here, we had the ringing, right? And then, okay, we don't have in this call, but because of the pickup from Charlie, you see there is this second branch, second invite for this from the call from Alice. This time going, okay, over here is actually Charlie. We have we can look at the invite. You see it's going with the URI to Charlie, and it also has this replace. See here, the replace header for Charlie. And we have here the cancel. You see, sent to Bob. So the ringing to Bob was cancelled. 200 OK to the cancel. 407 for this invite over here. So everything was cleared with Bob, and the invite and the answer is with Charlie device. And we have that at the end here, the ACK and by everything actually going to Charlie. So the call again first attempted to call to Alice, to Bob, and suddenly we have this new invite, new branch going to Charlie and cancelling the one from. Really? Okay. I wanted. Okay. Actually, we can do again and just show you the call from the second call, the one from Charlie. Unfortunately, SNGRED says a segmentation fault when I try to go back, so that's it. Let's do this again. Let's get this ready. So dialing to. Oh. Okay, so now again established and hanging up. Now let's take a look to the second call, which was actually the call, the red one, from Charlie to the *99. You know, just to see, as you see, it's something simple. There is only just two entities. Charlie talking to OpenSIPS, and that's it. OpenSIPS is a user agent server in this case, so it's not proxying to anything. And we have this 200 OK, which is actually sent by OpenSIPS in script when we do it, like the send reply. And this is we have the buy here, and the 200 OK again, we intercepted the last step. We said, okay, let's send back an 200 OK for the buy. So, segmentation fault. Okay.
Why the retransmissions?
Why the retransmissions? It might be something about the ACK. Yeah, definitely, because I see it's 200 OK use SDP, so it's 200 OK for the invite, not for the buy. So probably, okay, I'm missing something in there to handle the ACK and to inform the TM that, hey, okay, you know, actually the ACK was received, stop sending the 200 OK. So probably the script needs, again, some small tuning because the default script coming with OpenSIPS, that's the one we use to start from, has logic to act as a proxy, not as an endpoint. That's why we had to add that small trick for buy. Probably something like that needs to be done also for the ACK, just to again to handle that. So yeah, that's the thing that I wanted to show you. More or less, the idea is the OpenSIPS script. It's complex enough so you can actually implement many class 5, let's say, features which are signaling related, so not media definitely, into the OpenSIPS config file while running as a proxy. So, for example, to implement something like that, you don't need back-to-back, you don't need to put calls through, let's say, asterisk free switch just to do like a call pickup. You can do with OpenSIPS script. And again, as time as the feature is at the signaling level, you can do like hunt groups or call parking and stuff like that. There are many other services you can do. The whole idea is just to understand the flows, to try to, how to say, to correlate the calls through events and things like that. Play a bit with the replaces to keep overlapping the calls, and it will be more efficient in terms of, again, implementing such services on top of a proxy rather than going into like you know, fully blown back-to-back kind of solution just for this kind of features. If you have any questions, we have like 1.5 minutes. Okay, Vlad, I know you. You can ask me privately. Okay.
Yeah. So from the, I don't think you were creating a dialogue for that invite from Charlie. Right. So.
Because we don't need it, it's not like something bad.
Well, no.
Yeah.
But if you were to create a dialogue, is that dialogue going to be like a first-class citizen? Because I know if you were to do that with like the back-to-back user agent, the dialogue that gets created there is not like a normal dialogue. So, like, can you use OpenSIPS to respond to a request, create a dialogue, and have it be as if it was a user agent server in that functionality? So like, so I could store dialogue state with that and stuff.
So basically, each call, so we have 2 calls here, and one it was in proxy mode, right? So of course you can use the dialogue support for that, it's not a problem. Again, we simply don't need for that, but maybe you need for other purposes.
No, I'm talking about outside of this specific use case, but like for the star 99 pickup call.
Yeah, for that, that's different, that's what I'm saying. So we have one call which is more like proxy mode, the second one, OpenSIPS is a user agent server. So theoretically, you can use, I think starting with 3.4, we have some new functionality that you can use from script and also from outside in order to emulate in a correct way from script level and let's say an endpoint user agent client or server side. So you could use, yeah, that one just to, you know, make how to say a nice interaction with Charlie from the perspective of the call. Okay.
Just a question about this, your cancel mechanism. Would it be nice to have, let's say, not to send a cancel an instant? Should the call, the other branch should be cancelled automatically on the answer on this injected branch? Means well, if you have branching calls, means one of the branches answered, so you're sending the cancel to the other one. Means not to send the cancel explicitly before the 200 OK.
It was before.
Yeah, here it was before, but not to send it before. So you answered the call, and then you're canceling the branch. So it means it should be done automatically.
Yeah, thanks. So basically, what you are saying, just to let the call to Bob keep ringing.
Yeah.
Yeah, you can simply take that cancel out when you do the t-inject. In that case, it will simply add one extra branch. Both of them will be running.
Yeah.
The whole idea here is, well, anyhow, you do want, let's say, the pickup, to do the pickup because either Bob is not able to, so in that case it makes no sense to keep it ringing, or because you actually want, let's say, to steal the call.
It's just a matter of seconds. A matter of milliseconds.
Yeah, but in how it's implemented in the TM, it's first cancelling and then creating the new branch. But again, if you want to keep the branch ringing, you just remove that cancel and it will work like a parallel calling. That's it. Any questions? Vlad? No.
So I think there's a couple of race conditions here, like first when between Bob and answering while Charlie tries to pick up. not really worried about that, but more worried about Alice canceling while Charlie tries to pick up. So is there any good way to send a byte to Charlie on the initial invite in case that happens? To Charlie on his call pickup link in case Alice gave up. Because we're sending 200 is okay there, but maybe the request gets cancelled, so you need to clean up that dialogue. Not going to be anybody cleaning up for you.
Yeah.
Can we do that without back-to-back, or?
There is no back-to-back.
Yeah, but for sending the byte.
Well, yeah, there is support to send, let's say, eventually to try to detect and recover from such potential, let's say, undefined results. So you have the, what's called the TUAC blah blah something request in TM that it's able to send to generate a byte from the script. Let's say if you detect something like that. But let's say in the worst situation with the call to Charlie, yeah, things are pretty simple. I mean, once you send the 200 OK to the invite, it for sure that eventually it will send. Okay, you need to be sure that if you are not sending the invite to the replaces to Charlie, to be sure that, okay, you hang up somehow that call. Eventually you can imagine some cleanup stuff, or probably Charlie will get tired and will hang up by itself. Any other questions?
So I see you have in the main role in your script use sleep, like making a sleep. So this is in order to make the second call established, to give time to answer the 200 OK to Charlie in this case?
Yeah, it's just to avoid any kind of races with the ACK. Usually just give a chance to the call to establish before moving on with, let's say, the new, with the replacement and so on. So it's just trying a bit to clean, to keep the things cleaner, to, how to say, create some sequences. It's not the nicest way, but...
That's fine. So the 200 OK you have with the send reply 200 OK is directly sent when you invoke this function? Okay, so you don't need to wait the route to finish to do the exec. So it's not, okay, that makes sense. Okay, thank you.
So on the 200 OK that you generated on the invite, that's going to effectively be stored. I thought I saw SDP on that, and so where is that SDP coming from? Because that was generated by OpenSIPS. I thought I had a VoIP or something like that. Yeah,
That's one.
Yeah.
And that's the SDP. Basically just to make the, because we are not interested in any kind of audio here.
Okay.
But you know, that's the way you have to play, to send some SDP. And here what we are doing, we are simply copying the incoming SDP and we are sending back the 200 OK. Of course you can try to generate something like with basically indication that you are not willing to send anything or anything like that. But that's basically that's the request. The request body variable, the $RN, the last one, or you can insert any kind of a text over there saying, okay, that should be the payload I want to send you to.
Like whole SDP or something like
Yeah,
that.
the whole, basically the whole body, whatever it is.
Right. Okay.
In our case, the SDP.
Okay.
My question was the use like.
Oh, okay. Okay, I think we are. Oh. Hold on. Who's next? Done. Okay, sorry, Dan, I'll have to buy you like 2-3 beers for the 5 minutes extra.
So, what about the CDRs? Because for this also the CDR will be logged.
Yeah, it depends on how you generate the CDRs. If you do like, you know, by default CDR means dialogue level. So from the dialogue level perspective, you will see just the end result of the dialogue means Alice talking to Charlie, right? But if you want to the CDR to reflect the whole sequence, like, hey, you know, it was an attempt to call to Bob and so on, you can generate the accounting module allows you to generate specific events, you know, manual in script. So when you do the actual pickup logic, you can generate some extra accounting information to say, yeah, okay, you know, there was a pickup over here, and actually Bob was the original target, whatever.
Keeping this in the CDR.
Yeah, yeah. So just to reflect the information. Okay, I'm quite over the time. Thank you.
Okay, so I think we can start. So my following tutorial is based on what my last question from yesterday from Igor, if you heard, that CGRates has a bit deep learning curve. So I'll try today, I came up with the idea today morning, so I can explain you a bit regarding the integration as well as CGRates. So I think at the end of this talk or this tutorial, you should see that it's not so hard to understand it and it's not so hard to configure it. So for this purpose, what I did was coming up with a completely fresh Debian 12 install, so completely empty, and I'll walk you through step-by-step installing both OpenSIPS and CGRates and making them work together and explain you, as much time as I have, a bit the configurations and what are the secrets behind it. So it should be like do it yourself and learn. You can also watch it later, it will be recorded, so you can learn easier in this way, I hope. Good. So it will be a bit difficult with one hand, but I'll do my best. Okay, so we can see. There is no OpenSIPS nor CGRates on this box. I take some comments so it can go faster. But these comments are also documented on our read docs, so you can also grab them from there if you are interested. And also, in order not to be any doubts, I just take the nightly 3.5, so we should be compatible with the latest OpenSIPS. Some utilities first. I hope the internet plays with me, but otherwise I'll just skip because I already have a snapshot of all installed already. So in case all takes too long, then I'll just skip the installation process. Okay. First will be the sources of OpenSIPS itself, and the second will be the sources of the OpenSIPS CLI, which we use, for example, to create the database which OpenSIPS needs. In all styles, so I don't work too much with sudo, with root access. So
you forgot the key.
Okay. I installed curl, but I forgot to paste it back. Okay. So installed, as you see here, we installed OpenSIPS, OpenSIPS MySQL, encrypted configurations, OpenSIPS CGRates module, and OpenSIPS CLI. And this, I think, is the heaviest part of the tutorial. In the meantime, for storing, for example, if you are doing routing, we need the DR tables, and then we need MySQL, MariaDB, and I will also with this install Redis server and the SIP tool if we get a chance to use it. I don't know how fast we go through the tutorial, because it might help us terminating the course if we reach it to the routing. And with after we have installed all of this, we can create the database which OpenSIPS needed via the OpenSIPS CLI. The password didn't really matter because it's a sudo access. So now we have in this moment OpenSIPS installed. So we go now installing CGRates. This one it's even easier because there is only one module to install, but we use GNU-PG for managing the keys, and then we can get the key, and we can move it to trusted folder. This was changed not too long ago. And we now, you see, we are adding the bookworm sources to the app CGRates list. We have two different packaging. We have one for previous bookworm and after bookworm because they change a bit in packaging for Debian. Was it? Okay, looks like it was completed. Then we update again. And the final command to install CGRates, apt-get install CGRates. So with this single command, you should get a full OCS available in your system and installed already. So you get routing system, you get statistics, you get fraud, you get all these Dynet, DNS, radius, all of these things with just this step. So in like, I don't know, 5 to 10 minutes we installed both softwares. Once we have this, since we have done the database creation in OpenSIPS, we have to do the same thing for CGRates, and for that we have you see a setup database script. So the same thing like we did with OpenSIPS CLI, we just create the database tables via this, and now we have also the database set up. And one last thing, since we support automatic migration of the data, we also need to set the versions, the current versions with which the engines understand, because we work a lot with objects, and serialized objects stored into the database, we need to know whether these objects are having the same, are compatible to our engine. So this is why we would set the versions inside databases. And to set the versions, you need just one command from CGRates, CGR migrator exec set versions. Now, let us check what did we install, because that's also an interesting thing for you. So you see here, there are altogether 5 binaries which CGRates, install CGRates did for you. The most important is the CGR engine, which is the equivalent of OpenSIPS binary. So it's the engine running all your capabilities, all the functionalities. Inside these engines, there are all the subsystems. So you will run this engine for every subsystem of CGRates which you want to enable. If you want to enable 10 different subsystems outside, each in their own process, for example, fancy the Docker architecture style, you can do that by just enabling the right service and running the engine again. So you need maybe 10 different configurations, but the same engine. Then you will see here a console. This is our user interface. So we don't provide a web interface, but we provide a console, same like MariaDB or same like OpenSIPS CLI. This console runs the same APIs which we recommend you to run if, for example, you want to manage CGRates from your own tools. As an example would be Postman or your own web interface. So you can build up your own web interface on top of the APIs. And I will show you how the console connects to the engine. And in the same way, you can build your tools to connect to the engine, because there is no difference. We only support one set of APIs. So whether it's our console or your tools, you access it in the same way. And since we do JSON over TCP, you can even get away with just, I will show you that as well, making a telnet connection to the port where we listen for APIs and pasting a string in there. So that's all it takes for you to start interacting with the service. I will then go and show you this, which is the next tool, the CGR loader. What do we use this for? When you start the engine, of course, it has nothing. So it has no data. It doesn't know, other than the versions which we already set, it doesn't know anything. So a user trying to call, it will be automatically rejected because there is no data about that user inside. So how do you insert data into CGRates? There are 3 different ways of doing it. One would be via CSV files, which we always prefer the CSV files because you can also archive them, for example, with Git. So you can version them, you can back them up, you can see differences and so on. So we like them. But of course, there are pros and cons towards using one or another. So these CSV files, you can load them via this CGR loader tool. It's a tool meant to take the data from your sources, the CSVs, and put them into CGRates database. Then there are also ways of not using the tool. For example, if you are working with a remote, for example, from your own web interface, you don't have to use the CGR loader. This is it's a more interactive way of loading data. So you don't have to use the loader unless you are on the system itself. And other way, which is calling, you have API to load also CSVs from remote via an API application, and the engine knows also to do the same thing what the loader does. But for us, it's like a handy tool because it's interactive and it shows us what it does. Then you will have the CGR migrator, which is, I told you, we support automatic data migration. So if we decide that we want to enhance the account with some new fields or new structure, account changes the structure, we will inform the CGR migrator, and when the engine starts, engine will say, I don't recognize this version, I'm not capable of running it. Please run the migrator and convert your data into something which I understand. So this is what migrator tool is used for. Again, you don't have to worry unless you reach a point where you need to migrate. And then there is the last tool, which is the CGR tester. This is a load testing tool. So you can because you know each setup is different. So if you want to know how much your own network can do, like how many CPSs, how many calculations per second with your own tariff plans, you can use the CGR tester to emulate RPC calls. The advantage of it is that it can even load the engine inside, and then it can show you the real performance, not to consider or to ignore the serialization over network. So you can use CGR tester for all these simulations or emulations which you might want to do. Okay, so now I will configure OpenSIPS and CGRates together. So for this we also provide files, like basic files to start with. They are not meant to be neither secure nor full of features. They are just meant to show you how to put the softwares together, to work together. Okay, so what I did, I copied now the OpenSIPS configuration. So I simply overwrote overwritten the OpenSIPS configuration in etc OpenSIPS just because it's default and it's simpler to work with it. So what I did now, I also I've overwritten the CGRates configuration, which is in etc CGRates. So you see there are very similar ways of managing. Since we all have the old school, we put the same configuration files in the same places, and the difference would be that CGRates configuration file, it's a JSON file. So it's not the scripting of OpenSIPS, but it's a pure JSON file, and I can also show you all the possibilities of CGRates. We have what we call config defaults.go. This is actually the file where CGRates looks in before reading your file. So it reads and loads all the configurations which are in this file. So whenever you start with something and you want to know what CGRates has inside memory, you should use this config default. So you see it's spread into sections. These are common configurations which we might apply for multiple subsystems which we run. So for example, this is saying that the default tenant is CGRates.org. First thing, what you want to do, you might personalize this with your own domain, with your own tenant. Then you can configure that the default request types are different than we have. Rated works very well for wholesale because it just tags CDRs with prices. It doesn't do any prepaid on it, so it's very fast. Usually it takes all the data from cache and then this will be like the most performant you can get out of CGRates, rated with fully cached data. This you can expect. We have done some emulations inside our labs, and you can expect something up to, I don't know, maybe 20,000 requests per second. So then you go to other subsections. For example, this one is to limit the capacity or capabilities of your CGRate service. By default, it has no limitations, so you can put as much load as you want on it. But if, for example, you want to protect yourself from, let's say, denial of service or something else, you can say that I only want to handle 200 CPS or stuff like that. So the system will limit the APIs which will answer back. And as soon as the caps are hit, then there will be a strategy whether we reply busy back or we don't reply at all. For example, not to give an attacker the feeling that we are under pressure. So, and then there is the RPC connectivity, which allows you to specify how the CGRates components connect between themselves. Usually, by default, it's all internal, so you can start all the components inside one process, which is also the fastest possible. And we don't really encourage running different components on different machines, because it will only slow you down and it will make your management life a bit harder, because you have to manage many services. So if possible, we always say run it on one engine, because it's the fastest and the most optimal. But as soon as you get more advanced and you learn your way, then you can configure multiple RPC connections between the components. And this is where you configure a database. So, for example, you know, we use two databases, DataDB and StoreDB. This particular DataDB is for faster access. So all the accounts, all the tariff plans, everything what we need to access in real time, we put it into a DataDB, which is usually no SQL. Redis and Mongo we support, you see here. Or we also support in-memory database. We wrote our own database, and we tend to use it more and more, because first of all, you see what's happening, all this ping and pong with licensing, and one day one software is open source, the next day it will not be. So we decided that, okay, we write our own database, and we also support it to dump it on disk. So the current database is on in memory, same like if you remember MySQL cluster wanted to do, or it had an engine in memory. The same is our one, and we are also working now to support like dumping on disk. You can also use this database with remote and replication, so you can build a cluster, like query. If I cannot find on my node, I can query on another node for data. So real, very big installation if you have one. And why is that? Why we offer all these facilities is because, you know, as soon as you put a lot of traffic, your billing tends to be your center point of failure, and the let's say Achilles. So it will be the weak point in your network because of the performance. It has to handle transactions, so it's a lot of states, and then you would need all the tools available to make it faster. And then this is what all the infrastructure we offer you, but by default you don't have to deal with all this complexity. So it's just there as soon as you get more steps and be more advanced. The StoreDB will be the one which stores like heavy data, like your CDRs, and it doesn't have to be that fast, but it has to be reliable, and it can grow big. So for that we can support either Mongo, so we have a single database which we use for both, or MySQL or Postgres, and in memory as well. If you want to just pass the CDRs like a rating queue through CGRates and then export them in real time to yourself. Like for example, this will be like you are receiving the CDRs in real time from OpenSIPS, but already rated, which gives you quite a cool setup. Then some other settings, as soon as you have time for it, you can look into it. They are split per module, so it depends on which module you want to use. For example, we were discussing yesterday about Diameter, then you will enable this here, and then you will have already a fully functional Diameter server, or Radius and all the others. Then let's get back to our story. So we have now copied both of these configurations, and I will now restart them. Okay, so you saw I have restarted CGRates. First I reconfigured and restarted it, and now you can see that I run it. It's actually the version of few minutes ago. It's from today. You see the commit was at 8 in the morning, and you can also see it. This is a very good way to detect if you have memory leak, because this usually memory leaks in CGRates reflects into how many Go routines are staying stale in life. So you can then look and use this console status command to see. You can also see the Go version I have used when I compiled it. It's a pretty new version of Golang. We always tend to look into the latest. Then you can see your node ID. If you have a cluster or if you have a big network, you can configure here the nodes which are running. And then you immediately see on which server you are connected. And now I show you what the console does in the background and how you also can communicate the same thing from your own software. This console has also history. It can run also interactive, and also it can run in batch mode. This is the batch mode, so I'm just post-pending my command after the console itself. So I will just do the status, I get it back, and you can see what's happening over the network. So same like you are doing the n-grabbing of the SIP protocol, same is what you can do with CGRates. So for example, this is a call towards a node in the API named core SV1, which is actually the service. We always have the node ID as the service where the APIs are sent. And then this is just querying the status. And you see no parameters, and this tenant and so on, it's just to, since we want to protect everything on tenant level. And now you see I received one answer back, which is JSON. I can format it and see it nicely. And now the same thing, if I do telnet, I think I didn't install it. Okay, you see I just pasted the command which I captured over the network, and I got exactly the same answer back. So there is no, it's very easy to create your own interactions with the software from within your own software. So whether you do Postman or you do some other tools, even Telnet, you just communicate with the service. And once you understand this, then you can start interacting, like querying attribute profiles, querying rates, querying routes, querying everything. Because you start understanding what the software does. So if you understand this, like configuration, the config.json, you understand this API is how you interact with the system, and you understand also how to load the data, then you should, from there, it starts being like easier to understand the system. And now I will load the data. You see, all these pre-made files are available through installation, so you just have to know where to access them. Okay, so the data was loaded, and you can see what we found in the in this folder, actually in the tutorial folder. If I go into this folder, you see we have a set of CSVs which are actually they are designed for each subsystems which we want to use as part of our demo or as part of our tutorial. So you can also place a README inside, and you can visualize it. For example, these files, you can visualize it by going directly to our tutorial here and look, for example, if I want to see, because I fancy attributes always. So if I want to see what's in my attribute profile, attributes files, I can look inside here. And this is the way how you can define data in attributes. So you see, first you get the profile ID, which you can repeat if you have multiple lines. So this one, for example, it has 4 or even 5 lines. And you see, we split it in different ways, so we can see these are attributes, each attribute in a different way. This one is just setting the request password in our request. Attributes will interact with the events which are coming from the switch. And you can also see the filters and all these particularities which are inside. So the same CSV files, you can visualize them in like Git viewer or something like a table. And once you have this tabular way, you can see how easy it is to have already a web interface in the form of Google Docs. Because you take this CSV file and put it in the Google Docs, and this calculator, or how they call it, or similar to Excel, and you then have a lot of power, because there are a lot of filters and joins and tabs and a lot of things which you can do inside already. So when you want to, because many are asking what is our web interface. Web interface, I personally prefer Google Docs because it's very easy for me, and it's a very complex interface. There are it's a lot of code put in. So I will edit my CSVs within Google Docs, and then I will dump it into CGRates afterwards. We even have the fancy loading directly from the Google Docs if you want to export it from there. So we can connect from the CGR loader to your Google Docs and grab the data from there. Then once this data is inside CGRates, for example, if I want to see this attribute 1001 session auth. You see here, the console tells me what I loaded. If I want a simple way, I can also take out the verbose part, and I will not see nothing. You see, it did the same, but I don't see it because we want to have it also user-friendly. So how do I see now what I loaded? I go to console. I can go to attribute profile. One second. And I put now the attribute which I took from the interface, and you can see now my object in the memory. So I can see my tenant ID, and then also to visualize it makes more sense. So I see my filters, I see all the attributes which will be executed once this profile will be matched. So all these tools are meant for you to have complete access to data and have as much as user friendliness as possible. We consider always profiles which are matching, and these profiles are the units of the subsystems. So all this logic in the profiles are interpreted by subsystem. In this case would be the attribute subsystem, which will make use of these units and will execute some actions. So you have to understand their logic, of course, but it's not that hard to deal with them. And let me just quickly go through the OpenSIPS configuration. And so since we don't have that much time, I will. Okay, so you see the first thing you will notice is the configuration of the CGRates. So what you have to do is from OpenSIPS is you have to point to the address where CGRates listens. In this case is on localhost on port 2014. This is we use two ports for JSON. One is 2012, where we receive normal JSON RPC APIs, and then 2014, it's a special case which is not really standardized, but it's actually developed by a guy in Turkey. He was pretty smart with this idea. It's a bidirectional JSON RPC, so your server can also work as your client over the same connection which was open. So OpenSIPS will open a connection to CGRates, JSON RPC connection, and over this connection, when we have to interact with OpenSIPS, we can also send back commands. For example, we want to disconnect the call when maybe the balance is exhausted, or we detect fraud. So when we detect fraud, we can send a command, JSON RPC command to OpenSIPS over the same connection. So we don't need multiple connections between us. One connection, it's enough. And another reason is when we synchronize the active calls. So when we go and make a call, we might have very small chance of losing the connectivity, you know, network flapping or whatever. And in order for us to know that we are not overbilling, from time to time we can ask OpenSIPS, hey, are these connections or are these sessions still active? Because we are billing them. You know, as I explained yesterday in Dynetter, it's stateful on both sides. So it will be OpenSIPS having states, and also we have the states. And we have to synchronize, because there were cases in the past when we did not, that we consumed the user balance until it was none left. And that was wrong. So we do that, and over the same connection we do it. And then this was just by default a derouting configuration for routing. And you can see here, all you have to do for an authorization to work. So you say, I want to know the maximum usage, because CGRates can enforce the maximum usage of your OpenSIPS calls. And for that, you just activate that here. I want to get attributes. For example, you can even store your passwords inside CGRates. And I want to get routes, but in this, let's just disable, since we are running a bit out of time. Sorry, Lorenzo, we started half an hour late. Okay, thank you. But I'll rush a bit. And then you can configure various source request types and things which you want to pass to CGRates. You have no limit. It's fully configurable. If you want to add any attributes and send to CGRates any attributes, you can do it here. So then any AVPs which you are using, or any pseudo variables which you are using in OpenSIPS, you can send to CGRates, and then you can also store those in your CDRs. So there is no like strict protocol between the two. And you see, you will be calling asynchronously a CGRates authorization and resume that into CGRates auth section. So this one, you see, it runs through the answer which we gave back. For example, if we have errors or something, we will not allow the call to pass to go through. And we also convert everything what was received from CGRates attributes into OpenSIPS variables, pseudo variables. And we use this like special while loop just for splitting the data, formatting the data, and putting inside, because you see there is no other enforcement, so it's all free protocol there. And then we enable accounting. So you see, for CDRs and MIST, we will enable CGRates accounting. So that means OpenSIPS will inform us when the call starts and also when the call ends. So we also can generate a CDR out of it. So it's not only authorization, although you can decouple. So if you don't want to do accounting here, for example, if you have a back-to-back user agent, I don't know, FreeSwitch or Asterix, together, working together with OpenSIPS, you can do just the authorization with OpenSIPS and CGRates, and do the accounting and your CDRs via Asterix or FreeSwitch or some other switch which you are using. So use OpenSIPS just a proxy, but still secure the calls inside the proxy. So you can do that by just not activating the CDRs here. Now I'll do a quick call. Let's hope it works. I don't know if I loaded everything, but I hope so. Stay. So I'll fire up my Zoiper user agent, and I'll call from one place to another. Let's hope that it works. Okay, I get incoming, which means CGRates allowed us the call, and I just started the call now. So what's important is for us to see the interaction again. So you see when the call hit the server, so you see directly when invite came, and then CGRates module sent authorized message to CGRates. So CGRates module inside OpenSIPS sent a JSON RPC with some data which the module sent. So again, by just n-graphing, you are able to understand what's happening. And this, the rest are APIs which the modules of CGRates use to interact with each other. So you can read that also as your debug. I left it on purpose on localhost, but usually you can put in process, so you don't see this on your network. But just for you to see the interaction. So there is the authorization, and you see here there will be the answer back, which gives some things back. For example, the password, which I can use for my digest authorization to use it. So I don't need any database in OpenSIPS if I don't want to. And then maybe attach my PayPal account for future references in billing or whatever. I can also see some LCR profile and some resource allocations, and it also tells me that I have 5,000 seconds available and some thresholds hit and so on. So from this moment onwards, the call is allowed to pass, but it was blocked. It waited, you see, from 3969, it was blocked, so 3962, so few milliseconds, like 7 milliseconds, it was blocked waiting for CGRates to reply. The call did not go through unless CGRates allowed it. So you should be able to secure your calls in this way. And now if I just hang up, okay, I should get, but I stopped the end grab. However, one second. So I can see my call, which I just did. You can also see it as billed, so we can also see a cost attached to it. So, and we also see the cost details, like CGRates will tell how it calculated everything. If you have to be lawful compliant, this is very important because people, they check these things, like you have to report exactly what you do. And with these logs, you are sure that you can be compliant to any kind of checks they want to do on you. And then also the extra fields, you see the LCR profile which we send back from CGRates to OpenSIPS, it finds its way, also the password or this. This is just data which we randomly inserted via CGRates. So I ran out, unfortunately, out of time, but basically you can see how the interaction is done and how you can understand easier and make it more user-friendly. And grep a lot, and then APIs. So JSON RPC APIs are your thing. And come on our Google group, we are very happy to support community there. So ask any kind of crazy questions you have there. There are no easy enough questions. It's always important that you start from somewhere. And I know people using Google searches as documentation. So Google searching inside our Google group. So it's a lot of things are already sorted out there or answered there. So that's it from my side for today. Thank you very much. Anybody, any questions in between until Lorenzo comes and sets up? Great. So enjoy, guys. Thanks.
I'm not in the way, right? Like that. Ah, I'm not. But. Okay.
Sembrava settimana, la gente fa tutta la stessa cosa. Sai, tipo forse il polo A, no? Ma forse avevo capito male. Cioè tipo che era karaoke.
I don't remember who had yesterday the magic adapter for Mac for HDMI that used to work with both screens. What? Ah, and he's not here right now, right? Oh yeah, it looks like the same. I mean, yeah, let's see. Thanks.
Ho ancora troppa paranoia per entrare nei meetings con i tre, perché poi probabilmente fa cose strane. Quindi è per un caso di...
Okay, the magic happened. So we have next workshop. Lorenzo Mangani from KXIP/Homer. Yeah, showing us again some magic about the capturing.
Thank you, Bogdan. All right, good afternoon. Good afternoon. As usual, we'll do a little bit of hijacking. So, the title is a bit generic, but we want to keep as much as we can of this interactive. You made it all the way here. So, the topics and what we'll do exactly will, depend on your interaction. So, if you don't mind, let's keep it interactive. I gotta look up the screen because I don't see anything here. I'll be joined by Alexander in the second part, right? The first thing I wanted to do, which might be a little bit boring, but I think it's necessary in this moment of transition, is a short reconsolidation of what's actually under the hood when it comes to the latest version of what we're building. To do so, we can of course compare it to the previous one, but it's just lessons learned, let's say, category. So in order of evolution, the first Homer was really just about zip packets, and that's it. You didn't want to do anything else. It was just a collector that you could search and find stuff. Then it became about correlation. Then it became about the team following. Then statistics came in, analytics, and expectations change over time, and you have to keep up with what people actually want. And the very core design of the previous Homer just wasn't made for that. So with this new version, we're really, shaking things up from that point of view. So in the past, it was just Homer responsible for its part, doing the mostly, encapsulation, indexing of, the packets and the protocols that we work with. But, it was kind of a cage. So, and if you want to do any statistics and stuff, well, you have to choose something external. What do you choose? Who knows? And then all of a sudden, you have a gigantic fragmentation where just because you make it possible to, send this data a little bit everywhere, people will choose a little bit of everything. And before you know it, it's unmaintainable and you don't know what to focus on anymore. This was like the problem to solve. When it came to integrations, it was our API. Are we, fantastic at, making the best choices and everything? Well, not really. There's people with a lot more resources that, have, made certain API patterns into standards, and we have to adopt them because it doesn't make any sense to be like an iron. And then options, databases, this very, let's say, mono use UI that was on top of the previous stack. They were all limits. Whether we like it or not, it was where we got stuck. So with the new stack, which is what we're going to be talking, answering questions, interacting about today, we really have this composition. So at the top, we still have what you know as Homer, which is mostly just a bundle of tools that we use to mirror packets, capture, move them around, encapsulate them, and it remains the same because backwards compatibility here is essential. So we cannot change anything. People spend years implementing HAP and making things work in a certain way. So that part is drop-in compatible. Moving from 7 to 10, the ingestion side doesn't change at all. So same agents, same protocols, same everything. What happens after is completely different. So in the previous version, packets came in and then they went into a database. So we treated everything as real data. But the reality is that this is not real data. I mean, we are a monitoring platform. We shouldn't touch anything, right? We are supposed to take the original packet, put it in a place where you can use it and never touch it. Right? Every time you do something like that, you actually endanger, the very nature of the platform. So it's for monitoring. So we changed route. We said, okay, this is a problem that people already solved way more elegantly when you go look at how it's done for logs or metrics and whatever. It doesn't really need a database. It doesn't even need to be indexed in a bunch of occasions. So that's the approach we took. So the new role of Homer as a stack is to take all of the protocols that make our life possible, and that only makes sense in VoIP, of course. Some people that run an API or some other type of web service doesn't have our problems, doesn't have RTP, doesn't have a lot of stuff that we have to deal with. So the effort of Homer 10 is to transform all of everything that's special in our world into something that's normal. So observability, just like everybody else. We want to go back into the big group and use all the toys, all the evolution, the same day it comes out, not 20 years later as it usually is in telecoms. If there's something cool, we're last. We only get it last. I don't know why it's like that. There's also a lot of hardcore knowledge in our field. People don't really want to change tools or adopt stuff. As the age goes on, it doesn't get better. And in telecom, the average age is quite extended. So, including myself, of course. So, the effort here is to make it normal. And as we try to make it normal, we run into the same issue again. Okay, now we can have, our stack generate, the packets, the logs, the metrics, the traces. Sorry. But when we talk about storing them, the same issue appears. Where do we store them? What technology do we use? Which vendor? How many, variants of these things? And then ultimately, you guys, when you have to deploy this stuff, how many things do you actually have to manage when you say, I'm going to install Homer? It's kind of a trap. You think you're installing Homer, but then now all of a sudden you're installing also a database, also, another backend, also some APIs. It adds up into a lot. So now it's, quite a long ago, we decided to make the world a better place. And we started working on querying, which nobody asked us to, we didn't have to. It replaces some things that already exist, so this is not about innovation from that point of view, it's just about making life easier. So to do what we wanted, we needed Loki, we needed Prometheus, we needed Tempo, we needed Grafana, and then it keeps growing and growing and growing, but they all do the same thing. But those guys, they designed them for their cloud platform, right? So the open source version that they give us is super fucking hard to maintain and deal with. You have to learn an entire new job just because you want to, look at some metrics. And then because those metrics maybe are related to some packets and logs, now you got to do a whole, year of school to understand how to relate these things, and they have a different backend, and one using S3, the other one doesn't, one needs a file system, the other one, God knows what. It was getting complex. So querying replaces all of that, and it's quite ambitious because, of course, who are we? We're just a small group. But it's a clone. So we re-implemented all of the APIs that made those products work, but on top of the same data storage, which is ClickHouse. We've been using ClickHouse and contributing to ClickHouse for a long time, long history there, and it was just the right thing to do. Customers and users around seem to agree. I know we're stuck on this slide, but it's really important that the verticality there is understood, because then everything else makes sense. So all of these APIs are re-implemented on top of ClickHouse. It's essentially, by the way, a transpiler. So we take all of the protocols, query languages that make Loki, LogQL, PromQL, Tempo, and so on and so forth, and we just wrote a super cool transpiler. They become SQL queries at the other end. So that, when those protocols change, evolve, or add features, we just, extend our transpiler, and behind we have a real data store. So it's not some type of, block storage, black box that you cannot interact with. It's a database again, one that's made for, people that need to actually comply and deal with surprises, right? So if something bad ends, into your data set, how do you take it out? Good luck doing that with the originals. You would have to drop, an incredible amount of data just because inside there's something that's problematic in that. So that's the effort. And at the very bottom, the other problem, the UI. So developing a UI, especially for a small group, it's fun, but it's, it's an impossible mission. You can never make everybody happy, and you're always behind, the big guys and the big standards, and people have expectations. So right now, and it's not forever, but all of this lives into Grafana. So Grafana is the only UI that's used in this context to do everything. So there's no more, at least for now, again, Homer UI. There's no such component at this time. We'll rebuild it once, it makes sense. But for now, it became Grafana app, plugin, whatever. It lives in a widget. It does the things that Grafana couldn't do, such as, doing call flow, searching, SIP. Grafana is really, that's the only thing it's not excellent at. Is like, give me a form so that I can search through the data. So we did it ourselves, and that's the stack. So if you go and, I don't know what's next, Yeah, that's, zooming out. So at the top, all of our, flagship platforms that we use every day to, build our stuff, complemented by a bunch of new agents, new technologies, and new protocols that we can throw into the mix. Why? Because things are complex. I mean, there's no way that just by sniffing SIP, you can make sense of what's going on in a complex platform, unless you're lucky. Maybe you're looking at a SIP-specific issue, but otherwise, you're gonna need everything else. You need, possibly the logs of the system that was running your application. Let's say you start, you get some issue, a quality issue, let's say, right? Something, boom, drops down, call starts failing, quality drops, media, whatever it is, whatever you want it to be. There's a reason behind it. It's usually not the application that's running it. It's usually going to be related to load, some special event. Maybe you're being attacked and you didn't notice. Maybe the virtual host where everything is running ended up on, crap host that doesn't make, doesn't cut it at that point in time. But you need to know the context to understand if you even should investigate, right? Let's say you get a slam of, SIP error codes. You need to investigate them if you already know that the host that your software is running onto has an issue right at the same time. It's out of memory, CPU, top flat. Then you wouldn't even investigate the SIP part. You would just say, I know why it happened, move on to solve the real problem, which with signaling alone you cannot do. So that's the ambition, is to make this a collector for everything telecom, but using the standards of the other guys. So here you can latch in an API, you can latch in your entire Kubernetes stack automatically, so that we have the inside and the outside of the box side by side, and you can just get faster. There's a bunch of stuff in the box. Now this is what gets hard because I don't see the screen. I need to switch back and forth. But yeah, if everything is here. So if you're curious to see what really makes a stack, type the link. I'm gonna actually open it. Is that gonna work? Screen to screen. Well, almost. Oh god, this is difficult. So, just an overview so that we can get a little. Better? Bigger? Okay. So I guess I'm gonna have to switch sideways. So what's in the box? In no specific order, as we said, we have Grafana, super simple config. The only thing, it comes with our special plugin. So this is where the magic happens. The flow panel was the missing part. Everything else is already there in Grafana. You can do all types of, charts. You can access all types of data sources. In our case, it's native. So if when you use our stack with Grafana, you don't need to install a special plugin for using our data because everything is the same as theirs. So we emulate being Loki, Prometheus, and Tempo. So the only thing you need is exactly this plugin, which is just a filler to do the flow, the searching. Then we have ClickHouse, which is really the backend where everything goes, and we can talk about this if there's interest. We can zoom into what goes into running ClickHouse, what's easy, what's hard. I'll leave it up to you guys then to choose. And then we have querying, which is of course on top of ClickHouse, and this is really doing everything now. So the Homer instance that you will see below, or the Haplify server instance, is no longer connected to a database. It doesn't have any backend. It receives packets on one side, it basically transforms them into either metrics or logs. So all of the seed packets and etc. are now essentially logs into a ClickHouse table, which of course our API uses, but you can use as well. So when it comes to integration, you're most likely not going to do it on top of our APIs, you're going to do it directly into the database. This is where we want it to go, so that people really have freedom to, use the data at the source, not through our, funnel of bottlenecks. Then here we have some complementary stuff. Node exporter, of course my phone is going to ring right now. Node exporter, which is just generating some stats we use in the demo. Vector, same thing. I don't know, many of you already are familiar with these agents, by the way, but if you're not, take a note and I will dig deeper. Alerting, etc. And then this is the trick part. So we have two HepGen instances. How many of you know what HepGen is or ever used it? One is more than I expected. Awesome. So HepGen is kind of like mini version of like a CP for HEP. We have to test a bunch of complex conditions a bunch of times, and if every time we have to test something with HEP, we have to spin up a soft switch, a system, and everything else, we'd be dead before we even get halfway. So we have HepGen. HepGen basically allows us to simulate the result of a complex system, and it's kind of like CP as scenarios. So you have scenarios for registration, multi-leg calls, etc., etc. In this case, I'm using it to do two things: to generate a bunch of normal vanilla calls, and then in between them, HepGen bad generates some bad calls. So one is using, let's say, a positive scenario, and the other one is using a negative one. So I'm injecting some, simulated issues into an otherwise normal flow. This is for the purpose of the demo, because in the demo we don't want to just show good and bad. It's always a mix of the two. And then at the very end, Haplify server. This is where basically everything else happens when it comes to our ingestion part. So you have, as always, listening sockets. So you can ingest HEP using UDP, TCP, or TLS, depending on if you're segmenting locally. So if you're operating on a private network, keep it simple. If you're over the internet, keep it safe. A few options, and you can see already there, the DB is in mock mode. So DB driver, mock, there is no database. And everything else goes through Loki. So basically the role of this worker is to send everything it can to Loki. And everything else is exposed through the metrics endpoint. So the other one is the Prometheus scrapable endpoint, which is going to be on port 1996 by default, where you can put it wherever you want. And that's it. You can have as many of these as you want. They're stateless, so you can spin them up, down, swap them, and whatever. They don't have any, well, except for the statistics, let's say, consistent. But they don't need to be correlated, because they just emit one-way data into query. So now when you have to think about scaling the capture infrastructure, it's a whole lot better. You just have to have as many of these as it takes to take the network load or the amount of packets. And that's all this stage requires. Is any of you running this compose for fun or have tried to, or is this a first? You're disqualified, of course. Everybody with a red shirt is disqualified. Well, then, yeah, I mean, it might look complex. First of all, let's go interactive. Do you have any, questions? Does this trigger, something immediate, like, hey, I mean, it makes no sense. Where is this? Where is that? Go for it.
Like, what components are required to run it, not in demo, but to run this? So
Sure.
no gen.
Excellent question. So you would only need Amplify server. Am I still there? Yes. So Amplify server, mandatory, you need it. You need ClickHouse and query. That's essentially 3 of them. So 1, 2, 3, and then of course if you want to see it, Grafana. So total of 4, Amplify server ingestion, querying second stage, ClickHouse the backend, and Grafana to see it all. So it would be essentially 4 components, 3 of which are not ours. So, well, general purpose, we pick them well. I mean, Grafana, has, 15 million concurrent users at any time, any day, any moment. So, well tested. It doesn't do everything, but what it does, we consider it, within an acceptable standard. Also because, people hire people. Whatever you set up here, somebody's gonna have to use it. It's not just you, right? You have a team, you have tier 1s, you have the people that you're gonna hire next year. If you put them in front of a tool that they have never seen, doesn't matter how smart they are, it's gonna be difficult for them to immediately go useful. Versus, using Grafana and everything else hopefully being a good choice. And for ClickHouse, it's so far the best all-up columnar database that we had a chance to put our hands on. It's open source. It does exactly what we need really, really good, which is like, finding a needle in a haystack many times. When you have a bunch of traffic and you're looking for one thing, you need something that slams. And ClickHouse, when, it's provided with decent resources, it does extremely, extremely good. We have setups with, millions of concurrent calls and statistics and whatever running on relatively small clusters. And or migrated people that needed 100 servers into a system that needs maybe 12 to do the same job. It's mostly because of ClickHouse and when you use it right. But that's the magic recipe. Is those 4 elements. Everything else is an extra. Of course, if you add input of logs, you're gonna have a bunch of log-related agents, and this is where it gets fun because since we copied everything, so those APIs are all standard, you don't need to use anything that's ours at all. So it's only about HEP and our VoIP stuff. Everything else is blank. There we go. That's how you know you're talking too long. Right, there you go. So everything else is default. So you want to send logs from Docker, use Docker itself. It supports Loki. You use any agent from Grafana themselves. They do some excellent stuff. Vector, or I don't know. The list is really, really long. And the beauty is that it keeps on growing. So that standard doesn't change. We implement it. If it gets extended, we go with it. We follow them really, really close. For metrics, the same thing. So all of the complementary stuff is the new WAP count. But that's all you need from, let's say, a stack perspective. How many of them? That's it could be also a follow-up question. How many of these instances am I going to need to deal with my traffic? That of course depends on if you're running in a super centralized mode, like you want one place into the world where you're going to send everything and you only scale it there, or if you want to fragment it in a million pieces because of compliance and whatever. And we can talk about it. If anybody has that type of issue, we have a lot of experience and use cases that we can refer to. Any other questions about this in general, or even about any of these components, how you should get it, what you need to know? How's it going, Alex? Well, that's the generic, and of course, trust me, this is one of those things that in theory seems incredibly hard and tedious, but it's actually made to save you time. So the real goal of all of these things is to make it so that you can find out what's wrong or find out a little needle in a haystack within seconds instead of hours, and without having to ever replicate issues with the customer. Yes.
So, how would you tie in the EBPF stuff you talked about yesterday into the demo?
Oh, we go into the next. So, actually, fantastic point, right? So far, it's all stuff that you already knew. So we're ingesting HEP, okay, we all know where it comes from, right? But when it comes to the other protocols, why do we need them so badly? EBPF is maybe the major vector, because, of course, it's another ecosystem where, yes, Alexander has our own, RTC agent in the works, and it's going to do everything that VoIP requires. But then there's also the other side, right? So if you're on a Kubernetes cluster, nowadays I think there's at least, I don't know, a dozen projects that give you, instant observability with zero changes, even inside of the applications that you're developing using eBPF, and we want to be compatible with those. And those come into standard protocols. So eBPF is going to generate traces, logs, metrics, and I guess in the future also, to some extent, continuous profiling data, which is what querying is for. So querying gives us this full ingestion API that Alexander can have fun with, and the next guy can have fun with, and then you can decide what's important to you. Because if your infrastructure uses a lot of X, then somebody's going to have developed a fantastic standard tool for X, and here you can just bring it into the mix. So it's about making non-telecom things make sense in our telecom-centric world. And the idea here now is to go a little bit, dangerous demo, risky mode. So we talked a lot about eBPF, and at the end, that's the fun stuff. So Alexander, I guess, is going to take us for a little journey into how you actually run it, and maybe a demo.
Yeah, demo. Yeah. Thank you.
Now it gets fun.
Well done. So we just configured OpenSIPS in the last 5 minutes. Yeah? So OpenSIPS runs. 1 second, let me make a demo. Yeah, it works. So yesterday, exactly, we discussed about this RTC agent, how we can capture one of the main point of in OpenSIPS stuff. It's how to capture data if it's encrypted. So it's TLS 1.3 if you don't have private key, and etc. 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 So let me show you. Let me make it a little bit bigger. No, it's too much. Or no. It's okay? It's visible. No? So we have OpenSIPS inside, which normally 1 second. So do you see it's listening on zip TLS? Yeah? We did not activate any zip trace module inside, so everything is fine. We start ngrep, yeah? And we have the Zoiper, thanks for license. It was for free, and now we make a call. Yeah? So do you see it's a TLS registration here and so on, and we make a call. Call was not established, and here's TLS traffic. So we could not even decrypt it because you don't have private key. Okay, we have here, but normally it's in real life you don't have private key. So how we can capture the data? So we have this RTC agent. Let me find. So we run RTC agent, like I said, you can compile RTC agent run once and run everywhere. Yeah? So it's a static application, and inside you can have these modules, which will be EBPF modules in the kernel runs, and if we run this OpenSIPS with path to binary, where it's binary located, so normally if you have, like guys from Voice Center, they have a lot of those Docker containers,
You can or use external mounting of binary, or you can run RTC agent inside of Docker container, and RTC agent will monitor only this binary. So we started, and let's make call. It's already, you see, it's already decrypted. So make a call. So this data, as you see, it's already decrypted. It's transfer TLS without private key. We attach RTC agent to OpenZip binary. We attach to user points to which call functions receive message and proto TCP send or proto TLS send. And we just get the structure inside, decrypt, read the binary, read the message, read destination IP, etc., and we can send it. So this is how it works. So you can install close to your OpenSIPs with RTC agent, like I said, it's static, and you can decrypt your TLS traffic without to enable HEP module inside. So also what you can do, we implemented this monitor, like I said, we can also capture, let's say, monitoring not only SIP traffic inside, but also some sys calls, what executed by your OpenSIPs. If you would like to see which functions takes a lot of CPU, what is latency, etc., you can also do it. You have some params in RTC agents, it's called syscalls, for example. You know, let's run syscalls and see how it proceeds on my laptop. Here you are. Yeah? You get like top output, equal weight. So for developers, it's very useful what is your OpenSIPs does on your system. Yeah? Okay. Make UI it doesn't work, but okay, it says. So on the left side, it said it's in nanoseconds how the function takes to be executed. So we have 2 points. 1 point it's exact entry points and exit points of each function, and we can make a hash map inside. It's already done. You can make measurement how many milliseconds this function takes to be executed. Also, what you can do here, you can attach RTC agent to any internal user functions. For example, you created your own model in OpenSIPs, and you can attach RTC agent to the function what you executed in your model. So it doesn't mean what you have to use for standard OpenSIPs modules. You can also use your own modules, and you can see all functions what you have in OpenSIPs. So you can call command show all user functions. Let me quickly copy it because it's one command. Again, it's just for developers. You see, it's here's a list. They're all internal user functions what OpenSIPs uses. So you can take any function, you can attach, like I said, to user points and to see data what is coming in. Also, another feature what we have implemented in RTC agent is network call. So what it does, like I said, it's monitoring of all TCP stuff, connections. So, for example, here I'm using zipsack, what is sent to TLS, normally TLS port, just comment, and it's a response. But here it will be, so let me make it bigger. So you see, it's just, it shows what is from IP, local IP to our port, sends data from remote port 333, and this was TCP closed because this was not the real TCP connection, it's TLS connection, so it's immediately closed, no, without fin and so on. So this is how it works. Also, RTC agent supports just normal HEP. You can send all this data directly to HEP. Also, we implemented in it's Netflix, yeah, Netflix EBPF monitor. we implemented some additional model which you can also monitor OpenSIPS and other, let's say, projects to send all information to OpenTelemetry collectors. So not only to Homer, but to Querying. Querying supports OpenTelemetry. Lorenzo will explain it next about how to collect data. And OpenTelemetry, this means what you can send all internal information about OpenSIPS, how OpenSIPS proceed on SIP messages, on logs messages, etc., etc., etc. So this is how it works. So RTC agent is, like I said, it's open source. You can take, download it, use it, modify. It's in Golang. If you brave and wants to make additional EBPF filters, you can do it. You can also install this. On C model is compiled it and so on. Shlomi, do you want to continue? Oh, okay. So thank you.
Thank you. For the walk, not just for the presentation. Let me just start to playing with stuff. Let me just go back a bit. So hi, I'm Nitzan from Voice Center, and it's a pleasure to show some case study of the amazing work that I've been doing with the QXIP. I do wear the same color of shirts, but I am not a QXIP. Several people ask me after handing out the t-shirts, but we're all brothers here. So, you also probably meet Shlomi. He's my brother. So he's my little brother. We're twins. I'm 10 minutes older, so he'll get the joke in 10 minutes. And what I want to show is a little bit of the cool, crazy stuff that the people here were crazy enough to do. And finally, some other people like you might understand me living next to crazy Shlomi all life. That finally found some soulmates that they can go crazy and wild and make all those dreams come true. So what I'm going to show you is a little bit of actual business usage, that the abilities that the entire team brought up, and I'm talking about querying with the Grafana, and I'm talking about the new OpenSIPS models that we've implemented inside. So we'll go over them. Great. And in short terms, because I have up to 15 minutes, perfect. I would like to a little bit review how we are taking an OpenSIPS, implement the Prometheus model, set some parameters there, and then with simple scripting we can add any business needed value, not necessarily infrastructure value. Like everyone here once and then or always as their life work are monitoring infrastructure of telephony. And there's always this generic CPU, heap level memory, hard drive, and that's what we need to live with, and that's what we know. And if the CPU is going wild in some virtual machine, you now scratch your head and try to find the right VMware, LXC, Docker container, whatever infrastructure you're trying to find, and see which application is abusing the infrastructure. And in that application, especially if it's OpenSIPS or Rabbit or any other one of those, so I heard your question from before, so I pulled out like a draft that I have that shows that we have it's a little bit small, but we have the Proxmox, Node.js applications. We're using the C-Advisor for Debian for some other collections of metrics from Debian hosts that we didn't find in other tools, Asterix, RabbitMQ, of course the OpenSIPS, RTP engine, MikroTik routers, and it goes on and on and on. And what the querying solution did is just like this HDMI adapter that when Lorenzo came up and we needed to get something plugged in to somewhere else just to transparent and be a proxy to move things around. So it just brought my attention that querying is like an analogy of, think about this beautiful black box that, like a transformer, you can change it from Type-C, HDMI, USB, whatever you need to whatever you need, and instead of installing 20 different microservices and databases and different infrastructure just to monitor the infrastructure, it's all-in-one solution that really brought us, you know, as a business perspective, we thought, okay, that's a very long walk in the park. It felt like a very long walk in the park a year ago, saying let's start monitoring everything with these tools, and only a couple of, maybe 3 months later, we already got much better observability. We're just investing the same resources we would have invested just in current solution to collect one more metric here or one more metric there from live that shows us that we need to collect more metrics. So that's a quick, you know, a high level of what we've done. The only thing that's new for observability was the querying server, and you see everything is connected in, like this black connector magic box. And we have the Grafana on the side to view stuff, also straight going into the querying. And all it needs is the ClickHouse, and we also installed the MinIO. The ClickHouse database comes with a cool feature that rotates the old data, unused data, like we set, for example, 66 to 33%, and all the old stuff is moving to the MinIO while having the good SSD, fast hard drives, pulling out all the data quickly. So that's in general what we did, and now I will go a little bit about the steps. So let's start by, of course, showing the OpenSIPS documentation. We can see the version 3.5, if maybe you can see. So we got a new script route with model parameters here that's called Prometheus, and we added the script route with my costume Prometheus route, whatever. And if we hop on to that same place, let's go up into the beginning of the CFG file in one of our repositories. Let's look for Prometheus. Let's start with it. Declaring the model all the way somewhere up there. So you can see here that we're declaring, for example, script route with Prometheus Extra. And if I go to the route, Prometheus Extra, you can see a whole bunch of the actual calculation of whatever business need we had. Now, I will just follow up one business need that I had that wasn't necessarily infrastructure or resiliency related. It was more about cyber, about IT and the right configurations. I'm sure everyone are aware of that part of the initial ways to trace that you've been hacked to your SIP or one of your customers has been hacked, that you suddenly see multiple registrations from the same user agent because from the same SIP username. So one example I want to follow up is to actually monitor each one of the SIP extensions, SIP clients that are registered to the OpenSIPS and confirm that none of them is not registered more than once, maybe twice, you know, not having more than one concurrent call, for example, or maybe two if they're conferencing. Maybe some of them is also conferencing while spying or on hold with someone else, so it can reach out to 3, but 4 is definitely something we need to look at, and not lots of 3s. And this is just one unique business need over an OpenSIPS server that the easiest way would be, other than just writing internal scripts or monitoring it in other ways, was to get this Prometheus Extra to, let me go to that bulk. Yep. So we're using a profile to query for the device/B, and you can see here that we are actually setting up a JSON with values. And the beautiful part is here that we get, you know, to do the volume and the name as OpenSIPS device profile counter. And that's actually the name of the new created metrics that we created for the OpenSIPS server. And going to the same server doing the slash metrics to see the metrics themselves, you can see that now we have a new type called OpenSIPS device profile counter as a gauge type. Well, gauge is a type of data for Grafana or any other, but it's actually exposing the data to be easily collected later into querying, into clickouts, and then expose it from the Grafana. And I started doing some stuff, but this is a nice graph showing the example of the last 24 hours in our Miami, one of the servers, and you can see that one of the extensions during the last 24 hours had like 3 concurrent calls, but the others had either 2 or 1, which is perfectly normal. And that's, I really think, a very cool example of observability that think about without this tool now asking questions, generic questions for any business need, like how many concurrent extensions you have per specific user, and voila, you can just select the data center, select the server you want to see, select the metric you want to see, and if you don't have it already, then you can just write your own script, and I think that's it for the small demonstration. Like, I would say that in general, not just about the querying itself and its genericness, but all this big, mentally heavy decision to decide to work with a different observability tool than you currently have. We're very happy, more than 10 years of happy customers of Puzzler PRTG, with like the unlimited channels. We have tens of thousands of channels, but the manpower that it takes to maintain on each and every host all the different data and all the different extra dependencies that you need versus, you know, with the EBPF visibility is a new data that is not supported there. It took us less, as I mentioned, than 3 months to get so much load of data that it took us 3 more months just to scratch our heads and say, whoa, that's too much data. We need to understand what's really important, and we have like group discussions, each department, each one with its own needs, the billing department, the anti-fraud, of course, tier 1, tier 2 with their own dashboards, and you know, every time a customer is reaching some permission limit and it's blocking him, why not have our tier 1 have them online, so if one of them is not even aware that he's blocked or disabled now because of some security measures that we took, the team will already have it handy in a dashboard, so really you can take it any business way and business directions that you want. Highly recommended. Well done, guys. Thank you very much.
Well, I know, I just want to say thank you, but you know, sometimes, I mean, it's amazing to sit on the other side, right? If you build something that smart people can use to build something, then, you know, at least we're on the right track. So before we close, is there any question, something that we left unopened? This is just the beginning, by the way, it's an opener. Now you know us, now you know what this is for, and of course, it continues online.
Yeah, also development questions about RTC, EBPF, how it works, how to tune. So.
It started in a few minutes, but just, you know, from now on, we want you to feel like we're friends. So when you open an issue, when when you reach out, if you get your question, you know, in 10 minutes, in an hour, next week, next month, you know, the channel is always open. This is what we do, and of course, we can only do it if people use it and they tell us, you know, how they use it or why they cannot use it. So any feedback is good. Even if you were to look into this and say, you know, it's not for me, it'd still be amazing to know, you know, what we missed and how we can get better. So, present and future users, thank you.
So, no questions, huh?
Yeah.
Oh, yeah.
I have a lateral question, but that's relevant about let's put all the observability and monitoring into one solution. And this, we use it since time immemorial to use Nagios, CheckMK, and those kind of tools to have monitoring about
how the hardware and the network goes as an infrastructure for our operation. And if I understood well, and I was doing some Google search in the meanwhile, you can use some adapters that send, that integrates what Nagios or Check and K already do into and make it like a series into Grafana that then can be visualized, and probably there is also some alerting or whatever.
Oh yeah.
And if you can give
sure.
An idea.
100%. Oh, sorry. 100% yes. Again, I go back to we are inventing nothing here. We're just like compacting an alternative. But Grafana Cloud, they thought about it all. So yes, first of all, this is exactly the case. So you can take that piece, that used to be a specialized platform, and now just make it into numbers. It ends up on the same dashboard as the rest of the data that on the other side of, let's say, the coin, without having to use a specialized thing. But then in Grafana. And I'm sorry we didn't show it today, it could have been an excellent idea, and it will be for the next, but the alerting is as simple as, if you can see something, you can alert on something, right? So if you can make a chart, like, the guys were just making with the registrations, I think it takes, oh, there we go.
I can show it.
We can show it.
We have 2 more minutes.
Because it's brilliant, and brilliant stuff is simple. So this is just about, setting a threshold.
If you stay in the same repository, you can cross-reference between packet loss and quality of service.
That's exactly the goal. Is correlate events. Too much CPU, bad MOS. Not enough memory, drop packet. I don't know. It could be anything.
So it's exactly, we try to combine all information in once, and you can.
Just to try and show it in 20 seconds. Let's say that the threshold that we want to alert our NOC team is 3 concurrent calls and above, like in the example I gave. So you can easily, from the visible graph itself, just do more and do like create new alert rule. And now it's asking for some specifics. Of course, the metric that you came from is already filled up, so you don't need to. You can always go and say, I want to go to alertings, new alert rule, and just get to this form, but it's already filling up all the data from you from the graph. Leaving you just to set up the threshold somewhere here. I haven't done it for the last few days, somewhere here. Anyway, you just said, okay, you can definitely use labels, and it's important. For example, NOC, like let's say team equals NOC, or team equals SOC for security operation centers, or like you can assign this for support tier 1, you can assign it to multiple tags, and then eventually the alerting comes with those tags, and those tags can drive later, I can quickly just show how it looks there. It can drive later the flow of on-call, of actually triggering alerts and alert groups for your staff members. This example doesn't have it. It's just the alerting.
That's the gist.
Mixing
everything
perfect.
Together in the same pot.
Exactly.
And still being able to.
Yeah, so I have an example here for like the team equals NOC, and then you set up on the alerting the notification policies, which is actually the emails and contacts that will get it. So you have like those assignments that you can do on the way, and it's really a few clicks away. Thanks.
You can even send a notification in WhatsApp and Telegram.
The chat, and plus it's Grafana, so there's a bunch of plugins. Some things are native, some things might need you to require to load an extension, whatever, or to make your own if you're like us. But it's still within an ecosystem of well integrated tanks. Thank you so much. It's really useful. So yeah. Cool. Any other questions? Oh, sure.
I have a question for Alexander about the RTC agent. How hard is implement another type of software like Asterisk with TLS in the RTC agent? In the EBPF? It's only copy and paste, or it's something?
Yeah, good question. Somebody asked. So somebody asked yesterday about Asterisk, I don't remember who, but the answer was, let's say, in Asterisk it will be easy to integrate, yeah? Because if you're working with FreeSwitch, libSophia, so we are not talking about something bad about libSophia, but yeah, even with libSophia, I did with Magic and did make a hook for Lipsaphere. For PGZip it will be even easier. Yeah, so it should not be a problem. It's just because I don't use asterisk since a couple years. I use free switch, but yeah, it's possible. So it's same way. You just in RTC agent you just create a module at asterisk. You attach to function. You get this. You read source code of PGZip, how the parameters has been passed to this function, and that's it. So it should be, let's say, not rocket science. Maybe music science, yeah, but not rocket science.
Then we're going to be looking for, some non-open source applications to do this with, of course, once we run out of the ones that we know.
Yeah, it's also exactly, it's good for everybody who wants to integrate it, even not open source project. Yeah? If you have some not open source project and monitor some functions, yeah, it's also possible because this is a trick how you do, how edit is Lipsaphere. Because Lipsaphere, like I said, it has many dependencies, structure, union, structure. It's, I don't know what Nokia way smoked this time, but they did it not in an intelligent way. Anyway, you have a chance, you have a binary structure, you can hex the code, print out, and for example, you send from your known IP from your known port, and you can find in binary with your port position, your IP position. And you can find with source destination position. And based on that, you can jump to, like we did in ICE for 20 or 30 years. You can go to this memory position, you can read this data, because memory position will be not changed. It will be always same, because it's a structured, peg structure in memory. And you can read it, yeah? So if you have not open source project, you can also attach to exported function. You can get data, you can read this data, and you can send this data to format, to query, etc., etc. So this is how it works.
Okay, the question is for you about the using the plugin for the Grafana. Is it just the data source plugin, or it's a bunch of the...
There is no plugin for query. It's no plugin needed because querying emulates being locky. So Grafana has it thinks that it's locky. Prometheus, it thinks that it's Prometheus. So we use the integrated. The plugin that you have seen us load, it's only for the flow display of Homer. So that's only if you're going to use this in the, in Homer 10, let's say, context, then of course you need to see the call flow, search. But that plugin is basically only replacing the call flow and the search, let's say, form search experience. Everything else, you need no plugins, and it works with any version. Right now, actually, there's a few little things we're doing to make it perfect with Grafana 11 that just came out. They added some new explore ways so that you don't actually have to write the query. It's even more, click and select. So the plan is to keep it plugin-less forever. The data we need a plugin, we did something wrong.
And also, for example, if you have tempo, you send some OpenTelemetry, you have this information, and you have alerts inside, and you can click and jump to call flow immediately from Grafana. So it's integrated.
Unless you need the call flows. Unless you need the call flows, you don't need a plugin at all.
But you can use any data source for this.
Any. Yes. Yep, absolutely. The idea is that Grafana doesn't know. So it's all, behind their back, and essentially query is a replacement of Grafana Cloud, but with a single data store. But that's what we compare against when we do the test, and the CI, it's all comparative. Passing the same test means that we, support it good enough, and that's the stuff. We're 5 minutes into lunch, so thank you so much for having us.
They're here, and usually they will not bite you if you come and ask them. Now maybe they're hungry enough, so enjoy lunch, and thank you very much.
so much in the middle of ESRP. I do want to separate these up. And also, I want
All right, guys. Thanks for coming back from the lunch. I know it was hard, I can see. We're like 15 minutes late, but I didn't want to rush you because, well, we're not going. I will try not to steal much of your time. So the topic for this workshop is building a functional CSCF, and what I will be doing throughout this session, I will try to show you how to troubleshoot and debug. Actually, the things I've been doing in order to get this right as much as possible. So things might get a bit technical. If they do, well, it's because we have to. Otherwise, we wouldn't be here. Right. So bear with me. If you don't understand something, ask. It won't be like an interactive demo, but it's always good to discuss and ask things and understand things. I may skip some steps, I might assume some steps, you know some steps, and you might not. So don't be afraid to ask if you have any questions. Interrupt me anytime. I can resume whatever I do afterwards. So, basically what you have on the right side is a backpack with some equipment that I brought with us. And after I unpacked it, it looked something like this. So, as you can see over there's an antenna. There's a 4G antenna made by Veles. We have on the left side, there's a server. There's a small HP server that is hosting all our core network and all our IMS stuff. Here we have a switch which has power over Ethernet that is powering that antenna and also powering, well, there's a small MikroTik over there that is just used for internet access and routing, has some routing capabilities. And that's it. Of course, you need to power up all those. We have that set up. It has been there for 2 days. It's somewhere over there if you want to check on it afterwards. But this is what we will be using to to play. So the bases will act as an eNode B. It uses it's the Nova 229 model, has like 2 antennas, and it operates on bands 38, 40, 41, 42, 43, and 48. Why I'm telling you this, it's because it's important. Those bands are not that widely spread as you may think. That's why we had a lot of trouble, and Giovanni helped me a lot with this, to find the proper phones to support it. So they are not that widely spread. This means, especially, actually, I think they are a bit spread in the US, because Veles is a US company. The producer of the antenna is a US company, and well, they probably promote their own bands. However, in Europe, it's very hard to find devices that do support this this band. We will be operating on band 42. We have the PoE switch, which is just like a regular switch. And on the HP, on the server side, we have OpenIMS, Open5GS plus IMS. Open5GS is, for those of you who might not know or haven't seen it yet, is like a network, a project that enables or creates a 4G or 5G network to create to. So it handles all the communication with the, well, not itself, it's a different project, SRS. But they are handling the communication with the antenna, and basically they provide you a 4G, an IP network, let's say, whether it's 4G or 5G. 4G or 5G, it's only the architecture that provides it. But essentially you will end up with an IP. And it also hosts the IMS. We have the MikroTik, which provides us internet. We put all of them in the PoE switch, a power over internet switch, and we have like a full network. Here you can find the IPs of each device. So this device has, the network is 150.1.2 is the IMS, and 254 is the router. We won't see the router that much because it's just there to route packages, and usually route packages outside of the internet. We could have skipped it, but we couldn't. We would need to have some sort of a. I would need to have a cord down to that place, or I could have set it up here. But anyways, in our test, we will be using 2 phones. We have a Xiaomi Redmi Note 9 IV. This is the first phone I found that could properly operate on band 42. And again, thanks, Giovanni did a lot of research and bought a lot of phones until found the proper one, because you could find a phone that is compatible with that band, but not necessarily that model, because every phone you might know, they have their US version, they have their EU version, their India version, and so on and so forth. So we did spend a lot of time in choosing the right device. That's why I'm insisting on this. And also we have a OnePlus 8T 5G phone on my right side. Both of them are operating on band 42. And in our pickups, you will notice that they have assigned these IPs. You might have noticed that they are from a different range. So it's 192, 168, 101, and not 150. Well, that's because these are the IPs that the Open5GS network assigns to them. So basically, I don't have my pointer here, but everything that's on the left side is the core network. And they also start a DHCP server for those. So basically, the 4G or 5G network creates a separate network for the devices.
Not necessarily. IPsec well comes later, but again, it's a network. It's not IPsec, not at this point. IPsec appears later because otherwise we wouldn't be able to send the initial register. So it's not encrypted, it's just plain text. A few words about Open5GS. It provides 4G network. Also is handling the control over the eNodeB, over the device. Handles users' registrations for the network, so we're not yet talking about SIP registration, and assign the IPs within the 4G or 5G network. Okay, talking about IMS, this is our, this will be our setup today. So this is within the IMS core. So we have the CSCF, which is PINS. We have the HSS, which is the database, the IMS database, because there's another HSS in the core, and we have a media gateway. Of course, in our setup, OpenSIPS will act as a CSCF. HSS is PyHSS, which is a new project, but it's quite new, right? I think it's a few years old. And for the media gateway, we will be using RTP engines. Now, everything runs in a Docker containers. We are using Docker Open5GS. I'm not sure whether you know the project, but what it provides, it takes the Open5GS project and deploys it in several containers. So it's just for easy testing, for easily building testing setups. So, well, it builds like a whole new network, a whole new Docker native network, which assigns these IPs for each component. So .21 is PCCSCF, .19 is ICSCF, SCSCF is .20, .18 and .16 is the HSS and RTP engine. And again, we still have we will be using the devices that have .2 and .3 IP addresses. And that's it. That's what we will be using in this workshop. Now, I think these are the slides that I want to show you. We might as well get it started. So, let's see. Okay. Is it clear? I think it's clear enough. Should I increase the font? Should have done something. So the guys on the back, is it clearly seen? Okay, cool. Let's wrap up. Okay. So first thing that I want to do is to start the whole stuff. So I have a service file which shows all the containers, and they're currently being stopped because I stopped them before this. We just need to start all the containers. You might notice that there are a lot of components. Each component, if you remember our presentation, Livy's presentation and my presentation, the IMS has like a lot of components, and we're only talking about the 4G setup. This brings a lot of Dockers containers, as you can see. The first one is the PCSCF, the second one is SCSCF, ICSCF. Well, this is something that I've been using for testing. This is MME, SGWU, SGWC, UPF, HSS, SMSC, PCRF, WebUI, RTP engine. Well, a lot of containers are being used for our setup. But we will only be talking about the ones I've showed you earlier in this picture. So the media gateway, well, we will not look at it, it will just be there, and I will show you why. PCSCF, the CSCFs that are running OpenSIPS AGSS, and that's it. Oops. Okay, so let's see how. Okay, probably all of them are starting at this point. Now, what I would like to do, the first thing I do when I'm trying to look into this is start assembly, because it gives us like a high level idea of what's happening. And also, I usually run in parallel a TCP dump. We will see later why. So now, the first thing to do is start the phones. So here I have the Xiaomi phone, which is in airplane mode because, well, the antenna was turned off earlier, so it couldn't connect to it. But now I'm turning it on, so I'm just unplugged. You clearly can't see this, so I will just describe what's happening. So I will turn airplane mode off. What it has done, it's simply connected to the 4G network. So here on the upper right corner, you can see a 4G icon. This means that it has been connected to the network. But as you can see, nothing appeared so far. So nothing ended up in IMS because, well, IMS is only about voice and it has to be explicitly enabled. However, here I'm on the settings page, on the settings app in Android, and I have this small icon, small setting saying use VoLTE. As soon as I press it, the phone will register with the IMS subsystem. Here I am. I enabled it, and we immediately had a register. See? Perfect. Now, here I'm using a different phone. This is a OnePlus, same in airplane mode. I will just turn it on. However, this is one thing that I wanted you to see, that different devices, although they all use Android, they have different behaviors. So as you've noticed, as soon as I enabled airplane mode, this device automatically registered. So as you can see there, we have two registers. So now what I want to do is simply call from one side to the other. We have an invite. Okay, got a temporary. Did I miss them? I don't think I have the right number over there. Let's go from this side. Okay, this one is set on to automatically answer. So, yeah, I'll just test it. Hello, 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 hello. Put it on speaker. Okay, okay, okay. So now we have a full end-to-end call. So thank you so much. That's what I wanted to do to show you today. All right. Now, of course, I was kidding. So this is what we are working for, to be honest. All this stuff that you do on the Android phone, we capture everything, we took all the logs. That's essentially what we want to do. We want to make phones over IP. So it was that simple. However, you might have noticed that for this communication, I was tracking everything, but not port 22. However, for registering two phones and making them talk to each other, we used how many are these? 360,000, well, over 116,000 packets, right? Just for placing a call between these two. That's because a lot of stuff happens behind this, and and all of it is related to the IMS stuff. So yeah, let's try to dig into this. Okay, I will try to decrease the size here. Just do you know how to move this on to make this smaller? There's a command.
F10.
Which one?
F10.
F10.
F9.
It's L. No, not the, no, for
I think it's 0.
Increase, decrease.
0? Yes, I think so. Yeah, there it is. Oh, okay. Thank you, Flavio. No problem. So, what happens is, see this dot point 2, so 101.2. Remember, this is the actual IP that the phone is assigned to. So if you go to the settings of the phone, go to the network stuff, you will see that this is the assigned IP. And you can see that it's sending a register. What does this mean? It means that this register is actually, it's going over SIP, it's going over IP. So from our perspective, we just receive a register message from the phone. We will see later that it's not just that, but from the system perspective, that's all it is. And if you look at the message itself, it says it's coming over TCP, coming from the 101.2 IP, and it has all the it has some headers. If you remember, from my talk 2 days ago, for IMS to work, it requires some specification, and basically the SEC agree, which is RFC 3329, says that we need a secure channel for this communication. So the user requires SEC agree protocol. And here, where are we? Where was it? Oh, sorry. Let's open this one. It gives us a lot of information about how can we secure this channel. So this is what this header does. It's saying we need to use the IPsec 3GPP security scheme, which encapsulates everything in ESP packets, that whole transport. Gives us the SPI, if you remember, I've talked to you about them. Gives us the client port and the server port that the client needs to be reached at. And also gives us some algorithms that we can use in order to encrypt our traffic. And it's not only one, as you can see. So this is one method, this is a different method, this is a different method, and so on and so forth. Well, now you'll find a capturing problem, because if you take a look here, it starts another message. Well, I think this is just an SNGREP issue, because if you go to Wireshark, the message ends up here. But anyways, so the idea is that this register comes with a requirement of using a secure channel, and gives us some parameters about how this secure channel looks like. We take this register, send it to the ICSCF. If you remember from my presentation, the ICSCF asks who's in charge of handling this register. And it needs an SCSCF, which is this register right now. Okay. there was something else that I wanted to show you, that there is an authorization header. However, this authorization doesn't have a response. So basically, this is the specifications just say, well, just send an authorization because we need this username. This username is the IMPI part of the authentication scheme that we've discussed. So both Giovanni and me talked about IMPI and IMPU. This is the IMPI and the two header is the IMPU. Well, of course, as you can see, they somehow overlap. So this is a URI, which is 001010123456745, and authorization is the same. However, the IMS allows you to have as many public identities as you want. However, there's only one private identity. Okay, sorry. Going back, so we've sent a message to the SCSEF, and now we get a challenge. Now let's see what this challenge looks like. So it's like a basic www authenticate header. However, the algorithm being used is AKA v1 MD5, right? So this is the AKA authentication method I've discussing with, and it also comes with two different parameters. It's the cipher key and the integrity key. If you remember from my presentations, these are being used to establish IPsec tunnel. And I'm not just showing them because for you to see, but these two keys can be very useful further. We'll see about that. Okay, we send the 401 back to the PCSCF. As you can see, just as it is, it has the CK and IK parameters. And then we send the 401 back to the user. Now, as you see from the www authenticate header, there's no more IK and CK. That's because those are confidential information. We should not send them to the client. The client should already know because they were negotiated over a different protocol with the authentication server. Sorry. And moreover, we also send them a security server header, which says, okay, we'll be using this IPsec secure channel. I'll be waiting for a request on this port. I will be sending from this port, and we will encrypt our session using these algorithms. Again, we're just sending the algorithms, not the keys themselves. Next, what do we have here? So we can see here that there's a register going from PCSCF to the ICSCF. However, we don't see anything from the user itself, so we don't see anything from this side. Why is that? Because that register already came on a secure channel, and SNGREP is not able to see them. So we got the register. This is a relayed register. If I open it, you will see that it has been sent. It has been sent from the user, has passed through the PCSCF, and is going to the ICSCF. It also has like a full authorization header. This time we have a response. Where is it? Here. And it also has this small parameter, which is integrity protected. This parameter is being added by the PCSCF to the authorization header, so that all the proxies in the path, ICSCF and CCSCF, they should know that this is a secure channel. So because as you can see, nowhere else in the message can be seen that this register was received by us over an IPsec channel. Anywhere. The vias are like UDP and TCP plane, so nothing. Well, it does have like a proxy required, but okay, it's just a requirement. It's not something that it's clear that the message was received by the PCSCF over a protected channel. And this is what this parameter has to do. So basically we add it just because, just to tell everyone that the register has been protected. Okay, so we take this register, we send it further, add another via, and now the CSCF authenticates it, and it will send the 200 OK. And that's it. Again, this is where our trace ends because the 200 OK is not being relayed. Actually, there's one more thing I wanted to do. I will now disconnect the devices because I want to show you something else. So I turned both of them in airplane mode. At this point, we should get, as you can see, so after 800 seconds, not sure if it can be seen, but there are 793 seconds, we get a re-register for with probably it expires 0. So with, where is it? Is it? Oh, no. Yeah, there it is. So it's an expire 0. It's basically a deregister for that user. Okay, we challenge it. We challenge it. Probably this one was. Let me see. I'm just trying to see if. No. No. Anyway. I thought it was an AKA resynchronization request, but it was not. We challenge it again with a different nonce and then send to 100 OK. And at this point, the users are off. Okay, so this is more or less the registration part. For the invite, usually this is not just a simple call. It's a call that has certain requirements. They are called preconditions, and these preconditions can influence the call differently compared to a normal call. Let's see what happens. So we have an invite which is going over UDP, actually TCP. Sorry, is it? Yes. So it's received over TCP, sent over the TCP. Again, as you may notice, on the left side we don't have the user, so the invite is not received from the user. We have an invite going from point 21, which is the PCSCF, going to the SCSCF, and then back to PCSCF. So you may notice that these are two different, are the same IPs but with different ports. That's because this invite comes over UDP. There you go. So it was easier, it was clearer that, because otherwise we would have seen only 2 columns and it would be harder to understand. But more or less, the left side and the right side, they are the same thing. So this is the message operated invite, this is the message terminated invite. We get a 183, sorry, which we rely to the caller. Now, we need to check this message, and you will see that it requires one target rel, which is handling PRAC messages, and a precondition. Well, this precondition refers to the way media is being established between the two endpoints. One more thing I want to show you that I forgot is that here we have a private IP. We have our IP, and .16 is actually RTP engine. So at this point, RTP engine is being engaged in the call. I'm not sure if we can. Actually, there was no media here. Next, a PRAC message appears saying, well, this message tries to satisfy the precondition. It tries to establish the media channel. However, as I can see, here we don't have RTP engine engaged, and to be honest, I don't know why it hasn't been engaged, but this is most likely why the call failed. because it's advertising its internal IP. So this is the phone's IP. We send the PRAC. Even though we get the 200 OK, which is again the user's IP, we can't talk from user to user. We really need to bring, because the 4G network doesn't allow end-to-end connections between clients. So we need to bring the media through our platform. We get the 200 OK, and then 408 temporarily unavailable. Usually this happens when the precondition is not met. I hope I haven't lost you yet. This is the successful call. We have 180, 183. There's a PRAC trying to satisfy the precondition. We get a 200 OK. Then we send another update, as you can see, with the precondition being updated, and as you can see, it has the right RTP engine IP. This is the 200 OK. Then we get a ringing, and then we get the 200 OK, which is ACT. And here on the right side, we have the media, which is unencrypted, going to RTP engine. I don't think I can move my screen to see what's in this side, but trust me, it's media flowing to RTP engine. And then we turn off the call. What's also interesting is mapping. Mapping these ports that are being advertised with the ports that are actually being used. But yeah, let's go to this. Let's say the second part of this workshop, where I show you how all these things are being done. Go ahead, Johan.
Can you show where you fulfill the precondition? Because I cannot see.
The precondition?
Yeah, where do you fulfill?
Oh, so the precondition, in this case, the precondition is to enable the media channels, and you will see them in the other pickup I will show you, because there are some diameter commands that you need to explicitly open the channels, the data channels. Okay, so I have the pickup a trace here. I just need to bring it on my laptop. Okay, on my internal network it usually takes a couple of seconds, but we are here, so we have to wait for 3 minutes. Sure, there's another question here. Go ahead.
What's the component doing the IPsec?
What's the component doing IPsec? It's the phone and OpenSIPS. So the IPsec tunnel is established between the phone and the on OpenSIPS. Yes.
And which model?
It's the new proto IPsec module that we've just released. I'm saying we've just released because it was released in the day we made the release. So on Thursday, I believe, we made the release at 2 o'clock, and the module was pushed at 12 o'clock. Not because we want to hide it, but that's when we completed the work on it. Documentation. No, it was completed before that, but I was too lazy to write documentation. Okay, so 6 more seconds, 5, 4.
So the IPsec is on the application layer?
Yes, IPsec is on the application layer. Well, it's both. Actually, application happens at the network layer. We will see that there are, but the rules are being dynamically added by OpenSIPS from the application layer. So we use the netlink interface to create a set of rules to basically, those rules say whenever I send some package over UDP or TCP, you create the policies. You say, I want to match this traffic against this, I don't know, filter, and I want it encrypted. So you will see that instead of sending the packet itself, so it's also from the application layer, you send the UDP packet. That's it. So nothing is done on the application layer. You just create the rules. But the rules whenever you send the message, if it matches the rules, it will get encrypted. That's how it works. And I will show you. I will show you in the pickup. Just bear with me a bit.
Just create the matching filters for.
Exactly. Exactly. You create the matching filters and the rules according to the information you get in the security client header, the information you match, you generate or you choose from the security server header, and yes, you create these rules. I could have actually I can show you those rules. Let me see. Okay, so we have these are the rules and the policy that they apply. We have nothing because we've deregistered our phones. But now if I re-register it, okay, there you go. So these are the rules. These are this IPXXFRM is like the netlink interface the kernel provides for you in order to create these rules dynamically. I will now, I've turned it off. And what it essentially says, if this is the SRC, this is the DST on port 6100, this direction out, because there's also direction in, just encrypt the traffic using this rec ID. And then here we have all the way you should encrypt traffic. The algorithms being used, in our case ECB and SHH for integrity, and how you select this. This is the request ID. Basically, this is how you should. It's exactly each phone, each device generates 4 flows. If you remember from my presentation, so these are the four encrypted flows that are being generated for each, and 4 policies.
There's probably a limit on the number of devices per BCSF.
Yes, there is a limit on the number of devices, and this limit is also because you have to reserve 2 IPs for each phone. Actually, you can overlap your IPs on the server side, so that's not a problem. The specs say that if you go register to a server, a user registers to a server, if you need to re-register, you need to dedicate 2 different ports, because if you use the same ports, it might be a security issue. So you need to dedicate 2 more. And if you have multiple users, then you have even more ports allocated. And they have to be on the same net, on the very same IP that it's being used. So that's one, let's say, hard limitation. There's also the SPIs that you can create. They are up to, I think, max int. So 4 million whatever. So that's another limitation on the number of, and you need 2 per client, so you can have maximum 2 million clients. That's another limitation. Okay, so here, well, we have a lot of traffic, as you've seen. But I usually, what do I? Let's put our ESP. Okay, I usually only look at this. This is what interests us in terms of IPsec. And well, yeah, as you can see, there's a bunch of there are actually a lot of diameter exchanges between different devices, but there are also exchanges from our devices. For example, if you remember, 101.2 is one of the users. This is actually the register that comes to us. This is the first register that we saw in the SNGRAM. And as you can see, this comes over over TCP. So it's a TCP message. However, it's not a direct TCP message. It goes through a GPRS tunneling protocol. So, and actually it comes as a user datagram protocol on port 2152. So this is what the Open5GS network does. So this is the communication that Open5GS does. That one, if you remember, is the antenna. So it's our antenna. The antenna talks to the Open5GS core. It sends a UDP packet encapsulated in the GPRS tunneling protocol. The module takes it, decapsulates it, and generates a packet from dot to dot 21, which is the PCSCF. And here we can see the register as we were following it. Also the security client, everything that we've seen can be found here. This is the register that we send further to the ICSCF, and here you can see that there's a diameter user authenticate UI error, user authorization request. If you remember, this is the request that's asking where is the CSCF that I should look at, and here is the reply, which is saying SCSCF on port 6060 is the server that we need to send it to, and then this resolves to 172.22.0.20, which is this register that we are sending. And at this point, we need to find out the credentials, the AKA, if you remember, the AKA authentication vectors. So we do MAR query, where we are asking for authentication. This is information about what we are trying to authenticate. We're saying that we need the digest AKA V1 and V5 authentication. Here we get a reply with all the information: authenticate key, authorization key, confidentiality key, integrity key. You will see all of these, you will see them in the 401 that we are sending back. So, for example, the integrity key starts with 451A. You will see them here in this. There it is. So this is the integrity key, it's in the header. We will send it down to the user. Okay, this is an AA, we might talk about this a bit later. And now, this message is very important. So this is what we are sending from the PCSCF to the user. And it's important because we're saying, hey, send me the request on port 6100. As you can see, the next message is a register that is coming from the user on port 6100. But it's not coming directly. Again, it is using an ESP header. Basically, this message has been encrypted using the SPI identified by this ID, and Wireshark is able to decrypt them directly. Why it's being able to decrypt it directly? That's because we are probably using null ciphers. Let's see in the security header. Yeah, so we are actually not encrypting traffic using a secure cipher. So IPsec, Wireshark is able to decrypt it. That's why. Okay, we got a retransmission. This is the ACK, the TCP layer. Anyway, there are a bunch of retransmissions. They are not necessarily retransmissions, but I don't know. This is how Wireshark sees them. Okay. ACK. Again, we're doing all the stuff. We're trying to find out which is the server. And finally, we got 200 OK from that we sent back here. And that is it. Well, next the phone subscribes. We don't allow subscribe in this scenario. Return 405 is not allowed, and so on. There's a couple of. So now, if you remember, we registered 2 phones. Now we registered the second phone, which has IP.3, and it's more or less on the same path. However, what I want to show you is that on the 401 that we are sending towards, oh, it's decrypted. I don't know why. Okay, what I was going to show you is that usually the second phone, the OnePlus, usually doesn't offer the null algorithm, so it was requiring us to encrypt the traffic. However, we could what I wanted to show you in this, but apparently I can't, but I'm not sure why. I was going to show you how to decrypt the traffic, because Wireshark allows you to decrypt the traffic, and but I don't know why it does offer the null algorithm. It wasn't usually, but that's not a problem. I will show you anyway how to decrypt the traffic. I need to find an ESP protocol preferences. Here, I have here a bunch of rules. So. Again, we can clearly see the traffic in Wireshark because we are advertising the null encryption algorithm, but not all of the clients support it. That's why but we are still able to see this traffic if we create the rules. And all we need to do is set the policies that are being negotiated, manually set them in Wireshark. So we're saying if from PCSCF to this user that is using this SPI and uses this encryption algorithm and this authentication algorithm and has this authentication key and this encryption key, we can create these rules ourselves. Where do we take this information? Well, from the same place that the user takes it, or OpenSIPS takes them from the SIP headers. So this information is stored in the security client and security server headers. And these are actually, this is the CK value and this is the IT value from the header. Putting all of this here, it will automatically decrypt the traffic. So that's it. The only problem is that this is it needs to be manually. So you need to open the packet, copy paste each value from it. Do you have a question?
I usually put I export app from OpenSIPS from the
okay,
and I get it directly into SNGRAP, and you can deduplicate and get the packages in clear. And,
so you use Epic or?
Okay. From OpenSIPS or Kali or whatever, you send out the HEP that transit through the proxy directly to SNGRAP that is listening on the socket.
So it has a HEP listener?
Yeah, and it works. And you can also deduplicate, so you don't see, because when you capture on the Docker, you see many.
Okay, so Giovanni is using a different technique. This was my technique. I will tell you why I use this one, because, but anyway. So Giovanni is saying that SNGRAP has like a HEP listener, so you can duplicate all the traffic through HEP from OpenSIPS to SNGRAP, and you will see the entire traffic. And then you need to deduplicate, because you will also see you will see both the HEP traffic and the UDP traffic. And that's right, yeah, it works. The only way when it doesn't work is in development stage, where I was, and my IPsec tunnels were not established incorrectly. So from that part, I could have shown you. You will not even see the TCP header, because the packet is encapsulated at this header, at this level. So you would see that there's an ESP packet coming, but you don't know where. And it's usually your fault because, well, for example, I was testing if I'm advertising the correct port, if I'm advertising the correct algorithm. I was troubleshooting that, so the low level part, and because I wasn't getting a register, so I wanted to see where is this ESP packet being sent. So I really needed to understand exactly where the user was trying to send it, where it was trying to connect it. So I had to explicitly decrypt the packet, and this is how I was doing it. But yeah, your point is, and it's way more simpler than. This is like a very manual work, I mean, because you need to export the packet, you have information in the register, you have some information in the 401, you have to put all of them together in order to get the channels. And it's not that easy. Okay, moving forward, here we got an invite, but I'm not going to show you about this one. I want to show you about the successful call. I believe it, no, it's not, this is the outbound call. Bear with me a bit, please. Oh, this is the crack. Should be somewhere around here. Actually, it might be here as well. Sorry? Oh, right. Okay, let's do something else. Let's try to filter based on the command. There's one more thing I wanted to show you. It's for 21. Okay. Okay, yeah, it's this one. Okay. So remember we were talking about the precondition Johan asked, and this is the invite. We send the invite to the okay. I'm not seeing this invite going to the user, so this could be this. I don't think Wireshark decrypts this flow because I don't see the invite going from the PCSF to the callee. So we might be able to decrypt that as well, but we won't because we have like an easier method that Giovanni mentioned. It's weird because see, we got a 183 coming from the client, but we are not seeing the one going to. So remember there was this X that we were sending from one port but receiving on the other. Wireshark only decrypts one of the channels. It doesn't decrypt the other way, the other channel. But anyways, what I wanted to show you is that when we get the 183, we do the AAA request. And we need to do that because we need to open the channel for the media. This is being done, where is media component descriptor? Oh, okay. So here, not only we explicitly say the flows, which is in this subcomponent. So here, we say permit in 17 is the protocol from this IP, this is the media port, to RTP engine IP and port. This is for each media session done. Similarly, it's the same. So this is the RTP engine IP. This is the port that is being using for this session, and this is the RTP, and this is the RCTP. If you notice, there's only one port difference here. Well, this is because that's how the default RTCP works. But besides that, not just opening the flow or opening the flows is not enough. You also need to dedicate the bandwidth, both the upload and the download bandwidth. So this is what is being done in this packet. And on top of that, you also need to send what kind of codecs. Basically, you need to send to the PCRF all the information that you have about the call. So this is saying that it's an audio call. Basically, this is a SDP stream. It says the RTP that you'll be using, codecs, all the parameters that are being used. Now all these is taken and sent to the PCRF, PCRF. Okay, PCRF. It is being sent there, which is doing like a reauthorization. So as you can see, this diameter command goes from PCSCF to the PCRF, which is .4. It does a reauthentication, reauthorization of this flow. It says, is he allowed to use that much bandwidth? If not, it will reject it. Otherwise, it will answer it. It will reserve that channel, and from this point, there's RTP flowing. From this point, there should be RTP flowing, flowing between the two endpoints. Okay. Now, let's probably go. So this is the stuff that I've been fighting for like 2 months now. So it frustrated me a bit, and I want to share with all of you my frustration. So thanks for bearing with me. Now let's get to the simple part. Okay, turn off. No, here. Configuration. So as I said, we have multiple Docker containers. There are a couple of them. Let's use a different. Here, this is the BCSCF. These are basically the things that you need to run it. There's a free diameter configuration for the diameter communication. There's the PCSCF dictionary, which describes the commands that the PCSCF is using. And we're also, of course, using the OpenSIPS configuration file. Let me show you. So here in this dictionary file, you basically specify the commands that are being used. There are a couple of default commands, but the 3GPP, as you can see here, we're actually using 2 different vendors that came up with their own version of AVPs. So it's 3GPP and ETSI as well. So here we specify what kind of AVPs we are using, what are their types, what are their IDs, which are their vendors. This is what we're using for this PCSCF. These are the commands that we are doing. But probably the most important is the OpenSIPS CFG. Now, here we have the UDP and TCP sockets. These are the sockets that the user initially sends the initial register. So we need to listen on them, but we also have to create the IPsec sockets. So here there's the IPsec socket created. Remember, we need at least 2 ports because we need to use one for the client side and one on the server side. This is how you specify them. Next, well, we have some Prometheus exports. The diameter setup here. RTP engine setup. But essentially, it works just like a registrar, like a proxy registrar. It gets the register and sends it. It adds a path and sends it to the ICSCF. And if it has a security client, it sets a flag. We need to set this flag because we need to check on it later when we get a 401. Let's skip this part for now. Here. So if the secondary part has been handled, all we need to do is create the IPsec tunnel. We also send the AAR command to open the IPsec tunnel, to open the firewall for the IPsec tunnel. This is what this control does. It works in two directions. There's the command, and just issues here. We just send the diameter command. Okay. So, bottom line, all you need to do in order to create this, to use this module, is to load the module, declare the two listeners, the two ports, and call the IPsec create function. That's it. When the 200 OK comes, it will be over a protected channel, and we just use the location, safe location function. That's it. As you would use for any other contact. Okay, when a call comes, remember we need to open that media channel, that media flow. We also do engage RTP engine. I'm not getting into too much details. I'm just trying to show you the pieces that I had to add it and why I had to add them. All these scripts will be available one way or another for you to play with. So we haven't packaged them yet because, as you can see, we still have some hard-coded values in them. So we need to make them nicer and easier to use here as well. But we are planning to do this as soon as possible. Okay, here. Here is the entire Docker Open5JS project that is hosting all the components. I'm just going through them, and we only have we have all our configuration here. So we looked at BCSCF. We can look at SCSCF. This is way simpler. So whenever we have a register, if we can't authorize it using the aka www authorize, we make an asynchronous call to challenge it, and when it resumes, we're just saying that the MAA command has been successful, and continue working on doing the. For example, here we're sending the 301, which is a, what is it? I forgot. Service. This is the command that we use to say, hey, this user is being handled by this SCSCF. 301 is a server assignment, yeah. Is the server assignment request that the SCSCF is sending to the diameter to say, hey, you will find information about this user here. And more or less that's it. So what I wanted to show you is that it is possible, and we've done it. It works, as you've seen. We have like more than a proof of concept. However, I use 2 phones, right? And we will be using more, of course. We will be using other antennas, but there are a lot of other stuff that need to be done or need to be put, need to be investigated. And like I said in my presentation, we can't do all of them. That's why we rely on the community effort to test and do all this stuff by their own. Now that I've showed you how you can troubleshoot it, you should be able to know yourself. If you don't, come ask me and I can help you out. And yeah, I think I somehow lost you. But again, if you ever want to play with it, just drop me a line and we will figure it out how to. I will try to help you out to make your own setup and try to play with it yourself.
Next month.
Next month. Flavio next month. Somebody else books? Nah? Only Flavio.
The card is already.
Oh, you have the.
LSRP is already there.
Oh, the antenna, you already have the station. So, yes. This was my presentation. Thanks for being here. I will now leave my colleague Livio to show you how to move to what are our plans to move to the next level. But if there are any questions, go ahead, Lex.
Any particular reason for the engine?
Sorry? If it's any particular reason for RTP engine, yes, there is a particular reason. I was too lazy to change it to anything else. So this is the way that Docker Open5JS comes. This is the flavor it comes from. You could as well, of course, use RTP proxy instead of it. It's just, it wasn't, I mean, I didn't need to do anything to use it. That's more or less it. However, the guy from Docker Open5JS, the guy that packages everything, headless separates, I think is very open to so I think he...
Did you use specific
Sorry?
Did you use any?
No, there are no specific, at least not for my setup. There are no specific, like, I don't know, transcoding or stuff like that. No. I'm just using it because I need to bring media on the course, in the core network. But you can as well use RTP proxy for that. There's another question here.
I saw in your PCSCF config that you were using for your pathlet a fixed value. Is that by accident or is it always that?
So you're saying that I use the path yes. So I was using for the path header, you mean? Or yeah, for the path header I used that's wrong. I mean the URI is correct and it should be there. However, you have to put whatever the ICSF tells you, not what I hard-coded. But I hard-coded it because it was easier for me and I only had one, so it was working. But yes, you are right. Actually, you should hard-code it, whatever you get back in the service route header that the CSCF adds when it is being assigned. But yes, that's a very good point. There's another question here.
Can you shortly remind us how much is it legal? To own your own antenna and play such things?
He is asking how much is illegal. It's not illegal, it's against the law. I mean, no, you can, of course, you can operate it, but you have to get a license for it. For our testing purposes, we are using a free band. We were not using the 42, at least not publicly admitting it. No, we were using it. Yeah, so it's not okay. I mean, it might be illegal, but I won't admit it. Go ahead.
It's a little bit better than Razvan said. So the equipment that you can buy transmits into the spectrum bandwidth that is CGRates, that is like a citizen band. So actually is unregulated, so you are not breaking the law and you are not getting sued by T-Mobile or Vodafone. You are not giving problem to other people on phones. It's supposed, it depends on the country, but it's supposed that you just tell to police or whatever, okay, I'm starting using this. But this, there is no license to ask, and because it's that equipment that you can buy is equipment like for a camping. So a camping lot where you put your caravan and you get internet connection in the mountain. And so it's a niche market, and it's for this also that you can get those appliances that are like 200 square meter or 500 square meters is very small coverage, and they cost very little. I mean, an LTE second hand now you can get 200, 300 bucks, but if you try to get a tower for for a Vodafone, it will be like 200,000 bucks.
Yes. Giovanni, what's the range of that cell?
It depends, but the one that you can buy very easily, that are base cells, the one that he showed, and I have also, is like 50 meter, 100, no, it's more than enough. It's a building, a very small village or a building, but it's a real thing, it's a commercial thing.
Yes, so I have full access.
And that's the opposite if you try instead with USRP or software-defined radio, and that's the range is 1 meter. 1 meter.
Thank you.
Thank you, Giovanni, for completing me. Yeah. All right, thanks for having me. Now, my colleague Levi will show you how you can get to the next level. Go ahead.
I mean, getting to the next level is a bit much with what I have prepared for today and generally for this release in OpenSIPS, but definitely we made some good progress and unlocked some critical part in achieving that 5G platform. So the major part missing was, of course, the HTTP2 support. Out of curiosity, could you raise your hand if you at least have a remote idea on what HTTP2 is, or at least what it brings to the table? Okay, so that's like one in 4 people raise their hand. So this quick intro should be useful to a lot of people here. It's not that new, the idea with HTTP2, right? The whole web nowadays is still running HTTP 1.1, more or less. I think it came around, anyway, the history is a bit longer with the speedy protocol and whatnot, but in terms of IETF protocols, it came into life around 2010, I believe, plus give or take a few years. Couple of years, and the idea was to how they thought this is definitely an engineer's protocol, not necessarily something that came out of the real life requirements, because they thought, as they had seen the web moving, that it was becoming a problem that the browsers had to open a lot of connections to the website in order to request that many resources, right? As websites were growing, there were many more resources to be pulled. Image there, file here, and whatnot. So the idea was to parallelize, or not necessarily paralyze, but reduce the amount of connections by fitting all of them into one transfer, on one connection. But how do you do that? You have to make it more binary. So in short, it is a binary protocol. It no longer looks well when you're doing a text trace. So you have to use Wireshark, and you can see here with this post, right, all of the data, the headers can be packed into this nice for a computer, right? For a human it is not nice because it's unreadable. And the payload goes into a data frame. So all of a sudden we are able to multiplex them over the same connection, right? So on paper this sounds great, and it means we should be seeing a lot less connections with websites, and overall experience should improve, right? But what it turns out in practical terms to happen was that actually opening a lot of connections is a good thing for user experience. So when you open up your Facebook and your browser needs to fetch 50 resources, why not open as many connections as possible, get them in parallel, and give me a nice response time? While they, on the operating side, they could just scale their service. They could just throw more servers at it, and everything is working just as well. So that is why HTTP2 actually never caught on. You don't see your browser making HTTP2 requests. If I'm wrong on this, please feel free to correct me. So unless you're specifically loading the, I'll show you this guy's website who made the HTTP2 library. Of course, he hosts it on an HTTP2 server website. Probably your browser will still use HTTP 1.1. So this is what it looks like. So the engineer's idea of optimizing the problem with a lot of connections, okay, let's use one connection and overwork the crap out of it, right? And not necessarily an idea that caught on. So this is why from HTTP 1 we are nowadays jumping all the way to 3, right? 2 was more or less a protocol that caught on, at least as we can see with the 5G. It is appropriate for industrial, for backends, for building backends, where I'm imagining that is why 3GPP chose it. So that's enough of the theory. Let's move on to how we implemented it in OpenSIPS. I came across this nice library from this Japanese guy, Tatsuhiro. I don't know what his full name is, but he did a hell of a job. It is well documented, it is callback based, it is really was nice to work with it. And it is actually based on lib event for the server side and for the listening loop. And it all came together into this new HTTP2 daemon. As you all are all aware of the already existing HTTPD that's in OpenSIPS. That is based on lib micro HTTPD, which does not have HTTP2 support, so we made a different module. Next I'm going to kind of show you a bit around the ropes here. I'm not sure how to hold the mic. I guess I can speak louder. A little bit of both. It's okay, Rosemary, I got this. Let me just load up the file and I'll grab the mic after. understand. Thanks anyway. I mean, you can still stay here, but not to shoo you away, sorry. Okay, so let's take a look at some of the critical sections. We've got the new module loading up. You can configure the listeners. It's a overlook detail. HTTP2 kind of seems to require the TLS connection. It kind of seems to be mandatory, so I went with that as well. The only, for example, not that the RFC requires that, but for example, the two major implementations, right, in Firefox and in Chrome, as on the client side at least, they won't even work with a clear text HTTP2 server. So would be interesting if you know if whether the 5G, what that was mandated or not, the TLS. Anyway. So once we set that up, it's only a matter of course, I'm talking about the server side, right? We are going to play with curl as initially, and in the final part, I'm going to play actually with an OpenSIPS, so we can talk OpenSIPS to OpenSIPS with HTTP2. So I thought it would be most fun to work with as an event route. This is also what I did with Diameter as well. So we get the requests arriving here. We get a bunch of useful parameters, right? Highlighting the request's content from method, path, scheme. Oh, actually, I don't think I put the scheme there. Headers and the data. Oh yeah, fun fact, the scheme is now a header as well. I hope I have a request here. So it's structured a bit differently. Okay, and that's as far as the request processing goes, right? We have all our data, we can do whatever we want with it. Now, the second part, we need to prepare the reply. So we can work from top to bottom, right? We can edit each header, we can add extra headers, as well as the payload. That is the final thing we need to take care of. And finally, we can send the reply back. Sounds easy enough? Let's fire it up. And I will be using curl first. So let's do a post to the server and maybe try to track it down in Wireshark. Why not? Of course, it is an unsafe certificate, so we need the K parameter, and that's it. We got a success back from OpenSIPS, so that's a good sign. Let's check the logs. We notice our prints earlier on. We get the fields of the request, right, from method to path to the path. Method and path, all the way up to the headers and the body, which in our case is empty because we gave it no data, right? Had we give it some, why not? It should also include it there as part of the data. Okay, and that's as far as the OpenSIPS interaction goes. The reply arrived back at our end on curl, the status success JSON. So let's see how we can decode it in Wireshark. I think that's also going to be a useful. Let's just fire up Wireshark and listen on localhost. Let's redo our test. And it's not decrypting. because we are using TLS 1.3, and this is the problem I wanted to highlight. Maybe it's of use to you. I'll just hit Control-Shift-P to go to protocols and go to TLS. And we need to configure that file with the debug, with a pre-secret master key. This is kind of what's required in, by the way, I've already set up the key, so that is not a problem. This is exactly what Razvan showed earlier, right? This list of predefined rules that Wireshark picks up on, and it decrypts that specific traffic that it finds. Here I have a source IP address, I guess it's both source and destination on a specific port, and it should use this key for decryption, but it was still not enough. You notice there is still application data there. We don't see any HTTP2. So there is this debug log file that we plug into it, and with curl, of course, we need to write to that file, and there is this SSL. I'm not sure if I know the key off the top of my head. SSL keylog file, I think it is. I hope I get it right. There we go, I found it. So if we give it this environment variable, it will nicely dump all of its secrets to this file, because these are transient. This is transient data. These are secrets which are generated with TLS on 1.3 on the spot. By the way, this is just. I would be interested to learn more about TLS 1.3, but I never find the time to do it. So, if you know more about this stuff, I would love to hear some tips. So it looks the same for us, right? If we gave it the variable, but now the file is being written, and Wireshark should pick up on it. And as you can see, already we are getting actually decoded data for our request. So it's exactly what we gave it, right? It's a post. Of course, this is HTTP2 stuff with it's all repacking of data, right? You get header frame, data frame, and why not open it up a bit and see the new. This is the reply actually. So let's maybe take a look at the request here. Headers, and the request's data is in a different frame. So it's kind of difficult to follow along. But so yeah, this is our payload here, the x-axis. So this is kind of what it looks like. So now let's move to the, I guess, next last phase. Let's get OpenSIPS to talk to itself, not to itself, to there will be two separate instances. We're going to get a, I've already prepared them here, so now they both boot up. We get a client here and a server. Why not, let's take a look, quick look at the config file on the client side. There was, fortunately, due to the nice way libcurl is written, I mean, I guess it's not to the nice way, to the big effort that was put into curl, this transition from HTTP 1.1 to 2.22 is seamless. So for our intents and purposes, the REST client hasn't changed at all. We can simply use the same abstractions as we had in OpenSIPS up until now, right? We had REST post, we had this REST append header file, the content type here in this parameter, output body, this one, and nothing changes. So for the client side, we pretty much had everything already. And let's add a couple of headers along with the request body. I've prepared here with some minimal stuff, but this is nowhere near a complete request for the 5G network. And let's talk to the other OpenSIPs. All of this, by the way, if you haven't noticed, it's part of this event route. that we will invoke via MI. So this is kind of a nice way of building logic into your OpenSIPS config if you didn't know about it already, that you can invoke just with a raise event command from outside, right? I don't need to push any SIP traffic into it. I can interact with it this way. So once we do this, we trigger the whole logic. Let's look at the client-side logs. Here it's talking about what it received back. I guess there's not that much to look at when building the request, right? It's the same old REST client that we knew up until now. Oh, also, maybe this is more important to note. Notice how we configure the REST client now. We force it to use HTTP2. This is, there are kind of different levels of restricting the protocol. By default, it's on 0, the HTTP version of the client, and then the further you go, the more strict it becomes. You can check the module documentation. For example, on level 3, it means it does only HTTP 1.1, and then on 4 level it does 2 with fallback to 1.1, or one of them adds TLS on top of it, I guess. And the last one is only HTTP2, and it pre-knows that. It doesn't even do the connection upgrade anymore, right? Establish a 1.1 and then try to send that switching protocols packet and see if it goes to 2. Anyway, okay. And on the server side, why not? It's a similar experience as before, right? With the command line client. We got our custom headers, we can access them, and we got the body. All right, any questions so far on the support, on the routes? I mean, it should be pretty intuitive and easy for you to build stuff with it, right? Dimitri, anything?
Why? You just shared with us that nobody using HTTP2 and you implemented that.
Exactly, exactly. And now I'm going to get to the why. I actually thought, since there wasn't a setup to work with, right? You need the whole 5G antenna, the whole core and all that. We didn't push that much efforts into this side, but I can give you a few insights into how the new requests map onto the old ones. So here is an example. Here I have in this picture, we can see the interaction between the PCSCF and the PCRF in the IMS networks. Oh, sorry. Make it a bit larger, yeah, that's a good point, thanks. Good enough. And in 4G, you have exactly the request that Razvan was mentioning, the AAR request, that allocates resources for the pending call, right? Allocate bandwidth for the uplink, for the downlink, and all of that stuff. So now in 5G, over the RX interface, but now everything changes in 5G. Even the PCRF, it's no longer the policy and the charging rules function, now it's the policy control function. Now it's a PCF. The request was the AAR is no longer there, right? Because we are no longer using diameter. So now its equivalent is this NPCF policy authorization create HTTP2 request. And on the way back from the PCF to the PCSCF is the NPCF policy authorization create response. No, it's the notify. Yes, it's something that doesn't sound right. It's the notify, and it's backwards, right? It OpenSIPS. I mean, the PCSCF acts as a server this time. So the equivalent of the RAR.
Is this the interchange?
There are several changes. Yeah, I just put like an example change, and yeah, I didn't get to study this part much, like, because it's
It's very different, but
right, since all of diameter was dropped, I doubt there is a one-to-one correspondence, because the whole network structure needs to cope with the newly added requirements of all that stuff with ultra-low latency, with a lot more devices connected to the networks. So I'm imagining that all of this. So here is an example of. Sorry, let's put that park that argument for 1 second and just see how this AAR translates into this even more abstract policy authorization create function, which has a lot of sub uses of it, depending on what kind of HTTP endpoint you hit. So just with this simple function, you can achieve all of this like a side bunch of sub functions with it. I'm not exactly sure. So let us take the one with the bandwidth allocation, right? I'm not exactly sure which is the one that corresponds one-to-one with it. Maybe the one with the data flow, or yeah. Yeah, so this is kind of what it looks like in the new networks. This is what we will be working with these policy-based control functions, and these should lead to. For me, it was quite tricky to follow this document. For example, it just mentions some attributes here. One problem I had, it mentions attributes of the HTTP post, right? But I didn't see, okay, how do we pack them? With it's for sure yeah, tricky to follow along. Do you have any questions here? I mean, I guess we all have a lot of questions here. Please go ahead, Fabio.
I have seen many companies using 5G, but using the old 4G IMS on the network. It's kind of strange. Do they need something specific? Because I haven't seen people using diameter even in 5G.
Yes, but because of the fallback, right? So, like we said, not yesterday, on Tuesday, you cannot have 5G without also keeping your 4G core to cope with the quite frequently occurring scenario where you lose coverage, right? You lose 5G coverage, so your phone has to fall back to diameter and the 4G interactions. So but as far as using diameter directly in the 5G design, well, in terms of what they say, these documents here, you never see any even the remote reference to a diameter message, gone. A diameter interface such as RX, I can search here in this document RX, right? It has 220 pages, and the only reference to RX, there is not even the word RX, it's in the links to diameter documentation. So the whole wording has completely been thrown out the window, and they've made new abstractions with these NPCF and policy, the stuff and functions. AF is the application functions.
This hasn't changed the anything else.
Oh, okay.
And even in our customer there is a 5G network. And everything inside is still.
It's still
the
diameter.
Voice, the
Okay.
IMS.
Interesting.
I did not know the whole.
Yeah. As far as the design goes and the architectural recommendations, it should have no more diameter left, at least in the new core, right? Of course, you should keep both cores to cope with either of the scenarios. Yes. Any more questions on this? Does anyone have any experience with these, the new policy authorization, create, notify, update, delete functions? And how would some traffic look like? I would love to hear it. Yeah.
How is the HSS?
Yeah, that's a good question. You probably will need an HSS if it's even called that way. I don't know what's it called in a 5G network. Who knows? I would imagine it's HTTP2 interaction, right? So yeah, instead of diameter. It's a bit strange. Why change so much, right? Just but
what I saw in project that I saw was an IMS that was running on the 5G. So they were, I think, how is it not? None of them were offering pure HTTP.
Interesting. Yeah, that's reassuring for sure for a lot of us. All right, so that would be it. That was the demo for today. Any questions for Livia? Oh, sorry, I missed them. So I've just been out to prepare the coffee break. So the coffee break is in the next room. After that we will have Maxim's presentation. So let's try to keep this coffee break a bit shorter, 15-20 minutes, and then come back for Maxim.
By the way, quick update, so just to be sure for tomorrow, for those registered for the training will not be in this room, but actually in the one over there, it's La Mar or whatever called, the one next to the toilet basically, just to keep it simple. Okay, it's a smaller room, same floor, but again, it's entrance in that side, okay?
imagine one of them, I can send you the signal for it, right? I will signal because that yes.
Thanks guys for staying for so long. It's last of us. Good to see you. But anyway, today I'll do a little quick overview of how any one of you can set up your local inference machine pretty easily, either on some kind of regular hardware or also can be done in the cloud as well. Right now this is more or less work in progress, but we built a framework I was talking yesterday about, and right now implemented pretty simple live translation SIP service that pretty much can be used to supplement any existing PBX setup or something like help desk or something like that. So it's I mean it's not super super performant, but you can get depending on your hardware, can get probably like 20-30 sessions at the same time, or if you have like local cluster, probably can get more. So we'll just go through like setting it up from zero essentially. We'll basically use existing SIP switch, which will source and sync calls for us. We'll use one DID number, so we can call in set up a VS instance to run the software, and we'll use soft phone to emulate an agent. So first things first, we'll get provision AWS instance. I'll use, I think Flavio mentioned this, it's called G4DN, it's T4, I think it's 32 gigs of video or something. Like that, it's about, I believe, $3 an hour. So, actually, no, it's 30 cents an hour, so it's not super expensive. So we'll get it going. I'll pick up just vanilla latest Ubuntu. We tried some of those images that AWS provides for machine learning, but they are pretty much overloaded. They provide like 10 versions of CUDA, and it's just it's probably for computer science guys or something. So get. Yeah, this is X large, blah blah blah. Let's use the key pair. I need a little bit more space. So for like frameworks and everything, probably need at least 20-30 gigabytes, because you will need to install a lot of drivers and a lot of CUDA stuff. Let's create a new session. Okay, so here we go. Continue. So it's pretty stock. Ubuntu does not have anything installed. First things we do install some NVIDIA drivers.
Max, can you increase your front?
Oh yeah.
Don't call.
The better. So yeah, so we'll just pick the latest 550. Yes, it's going to install quite a lot of packages, but it's only done once, so yeah, it can be automated and packaged.
No.
Already plenty of
Yeah, G4. No, if it's they have DM, NVIDIA, and DA. But this is NVIDIA, I think unless I screwed it up.
This is a CPU instance only, yes?
No, this is a GPU. It's T4, like really small GPU by today's standard.
It's okay. I will answer him.
It's probably built in the driver. But of course, this also can be Dockerized and run inside a container, and then the deployment will probably be much more smooth.
But will the driver works the same efficiency from the container?
Yeah, I believe you can just pass through the GPU, so it will be almost no impact. Will be probably a little bit of overhead, but
Test and see, like.
yeah, something very slow. Suspense.
I think it provides some operating stuff. Okay.
Yeah.
Okay.
Oh yeah. So now we rebooted everything loads. Okay. So now we can install some tools and we top.
Install. Yeah.
Yeah, so Tesla T3, blah blah blah.
EBPF. Is us. Put it in UTF.
Italians and everybody else.
We're fashion oriented.
No, wasting time changing font. Yeah, I don't know. Anyway, I'll have to realize that. Imagination. Now, the next thing I usually do is to install Miniconda. This is basically a package manager for Python. Again, it's not 100% necessary. It just depends on how you manage your Python modules. So in your production, you will probably have to figure out the way to do it. But essentially, it encapsulates all like Python dependencies and manage them as a whole.
Okay.
So now install Python. Usually at this point of time I use 3.11. Should also work with 3.12 and earlier versions, but seems to be safe. Okay, and the last thing that I do, check out the repository. Not the last, but the next, I guess. Getting almost there. Yeah, I said it's a little bit work in progress, so I created a special branch for OpenSIPS Summit, which basically has the same OpenSIPS workshop. Yeah, I'm still have not figured out how to do like configuration for different nodes, clustered, not clustered. Because in my setup I have like separate GPU for every actor. So I had a little bit of hack to get it all running on the single machine. But anyway, so this is the software, and I also need to install requirements, which is done with Python and pip. Yeah, it's a little bit of, it's a new module that I created. It seems like a problem with dependencies. I'll fix it after the summit, so I'll just install this manually. Yeah, now we need to twiddle fingers for a little while. So it installs all like Python frameworks and all that stuff. Okay, while it's installing, let's maybe prepare the C part. So essentially, as I said, we have to get some realistic calls into the system. Oh yes, there was a little bit of demo system we have here. So basically I had those two accounts, I'll just delete them and create new ones for demo. It's basically just a SIP account, nothing really too exciting. So it's one account I'll use to receive calls, and another one will be used to send them out.
Meow, meow, meow.
Yes, Alright, so now let's see if it's created everything. Oh yeah, everything is installed. Everything looks good. And the last thing that I need to do is to check the firewall, make sure I can actually send CP traffic to my switch. And this. Okay, and also wanted to check in AWS that we have selected the right security. Wow. Okay, it's 0, so good. Okay, so last thing that you need is some configuration file. I created simple configuration file. Basically, as I said, we have right now only single application called Light Translator. So the file is via mail. You create some SIP profiles, set some generical parameters like the bit address. And then the idea is that you can have several profiles, and each profile will have either particular application connected to it, which is defined later, or it can be used for outbound calls as well. And then you define a particular application, which is in our case, as I said, live translator, and we will be translating from English to Portuguese and back, essentially. And then we set since it works as B2B, essentially we also define outbound numbers. So we get the incoming call, we connect all the models, and we send it out and create pass-through channels, so you can still hear the other person in the original language. So now we customize it a little bit for the IP address. The local IP address, I already have IP address for my SIP server. and I connect one of the accounts. Here. So this will be my incoming account, and I set okay, so now it should be pretty much ready to start the application. So let's. The only thing that I can run it now, but it will fail. There is some particular issue with libraries in QDAS. So sometimes you need to put those the library paths or something when you cannot find some of the QDAS libraries. It's kind of annoying, but. Let's see if it starts. Yeah, so what happens in the background, it creates a kind of dummy on-demand cluster. So in another mode, you can pre-start those cluster nodes and then it will deploy on those. But for the purposes of the demo, I'm using this. And now you see it start downloading all the models and everything. So most of the stuff gets cached locally, so it only first time you start it. So unless there is some updates, okay. Okay, it says it's too few CPUs. Okay. Yeah, I can probably switch to the other mode type. Hold on a second. Looks like I provisioned different types of. Oh yeah, it says 2x large. Okay, makes sense. Okay, that's a little bit of bummer, but we can fix it. start in. Let's go to the address.
Max, font size, please.
Oh, yeah. Yes. Okay, so let's try Vim. Let's see if this works better. Okay, so I see it loads Whisper. Definitely getting faster now. So eventually the SIP stack will start and we'll see the registration attempt going out. As I said, it's first time on board, it downloads a few gigabytes of models and so it a little bit. Yeah. Oh yeah, so here you see we have registration request going out successfully, and we will have some kind of welcome call from our switch, which actually got connected somewhere, probably to voicemail, but anyway. Now the next thing that we need, the last thing, is to add the soft phone and connect the DID so we can actually complete our demo call. And so go back to the accounts. And you see there is a green button. This I can probably make it a little bit bigger. So we see registration successful. And now I just get my link phone. And I already have configuration, so I'll just update the username and password. Now I'm going back to the account list. So that's our soft phone, and I think we now connect the ID number. This is just a scripted call, it's not part of the demo, but come on. Right, went to this mobile mode, hello. So yeah, so basically we have this ID number 23, which we can use for this purposes of this demo. So basically assign it to the account that has been registered by the Inference instance. And now let's see if this all works together. Yeah, console. Does it work? Okay, so number is okay. Need some time to refresh. Oh yeah, I think it worked. So now, I don't know if you can see it, but basically it comes all the way through to the soft phone on the other side. Now maybe my fellow assistant, let me go to Lorenzo. Yeah, will be, I'll try to order pizza from you or something. Hold on, do we have audio at all? Hello? Hello? No audio. I don't hear anything. Oops. See. Maybe, can I check that?
Okay.
Let's see if,
Now?
no audio actually, hold on. Let's see the logs first. Maybe something and
Still some.
yeah, don't go far. Don't go far.
Don't go too far.
We'll debug it. It's there, it worked. Okay. Let's see it again. Check. I hear, no, I see your audio.
Hello?
So.
Let's ring it here, but not so much.
Okay, let me don't hang up yet. We'll do some live debugging. Let me check from second. Give me a second. Hello. No, sorry. Headphones, all good. Then hang ups, huh? So it seems like well. I guess we can run to speed up at least. Let's see what's going on. Hello. Yeah, I don't see any RTP going on here.
Maybe the security group, no?
But it's open. I can change it to one so I had it before. Okay.
You don't have any about rules. Source, destination, all.
Yeah, but it's because I'm using.
Add the rules.
Yeah, right.
Open the whole UP.
Yeah.
It's a good point. Let's say that.
That seems fine.
Yeah, how do I edit it?
It's funny that not even the 60.
Here's the button. See if we have a special one. I did not pick it up, but here we go. Okay. See. Okay, another one. Let's pick it up. Back to my console. Hello.
Vai, está funcionando.
Agora está funcionando. Hello. And now it's working. Or now it's working.
Agora está funcionando. Está nada.
Can I order some pizza from you?
Doesn't work like
Margherita, pepperoni or calabresa?
Pepperoni or calabresa? Calabresa.
3 pieces of calabresa.
Ok. 3 pizzas de calabresa sendo despachadas agora.
3 pizzas de calabresa sendo despachadas agora. Are being dispatched now.
Thank you, sir.
Very nice. And the pizzas are coming. 30 minutes.
Can I order something as well? I want to order something.
So can I use a few more minutes? Yes. Yeah, okay. So yeah, that was a little demo. Finally, we got at least some of it. But seriously speaking, I tested it myself by watching some of the pretty long videos on YouTube from like C3 conference, for example. They have pretty big German section, which they don't really translate, and it kind of works, and I think it can be improved obviously further. And with the idea is that it just for starters we use those models, but as we find better models for text to speech and speech to text, or some combined, we can at some point replace those or add as alternatives. What else is interesting? There is some pretty good debug and management for the framework. You can use look into like what actors you have running, what functions are being called and stuff like that. So pretty kind of well featured in that sense. Yeah, I didn't put the server with plan to put it some pilot deployments pretty soon, so hopefully we'll have more updates and improvements for the next this next summit. And if you guys have any questions or have some use case interesting that is not covered, yeah, let us know. We're definitely interested in hearing. That's it. Yeah.
Just to confirm, it's all running locally, means there is no external calls to the...
No, locally. Only external calls is to download the models initially, but after that it's all
so the
running.
translation, speech to text, text to speech,
Yeah,
is all
yeah.
local. Okay.
Yeah, if you're curious for translation, it's kind of interesting because I tried different schemas. So for example, if you have, for example, somebody need to translate from Italian to, I don't know, Dutch, how do you do this? Like, because Whisper itself is kind of multilingual, so it can also do translation for you. So one way to do it is try to recognize if it's Italian as Italian, but then you need to translate it to target language. Interestingly enough, with Whisper at least it's works better if you let it Whisper to translate to English first and then translate English to like whatever. But it's obviously very model dependent kind of thing, I guess.
With the hardware, how many covert calls can you handle?
Depends. I think with kind of like 40, 70, you should probably get to like tens of calls easily. Yeah, 20, 30 maybe, like that kind of thing. Yeah, but as I said, we're going to test it pretty soon on real hardware, so we'll probably post some updates on what the looks like. But at least that comes from just running those models in like development settings. Yeah.
So.
Can it be more than 2 languages, like I'm adding 3, 4, and the automatically detection? And,
Yeah, we did not really integrate automatic detection. Whisper has automatic detection, so you can probably utilize that as well. Right now we can load as many models as you need. So the framework itself is pretty much allows it, so it does not really matter. You just create more agents and then split out across available resources. Thanks.
Room on the other side of the hall.
At 10.
Sorry?
At 10. Or at 9.
Livia? Can you check on the website of the training? It's 10 or 9? 10? Okay, let's make it a 10. Yes. Yeah, okay, so 10. Now, we are done for today. So basically with most of the things with the summit. So, okay, we are less a bit now, but I would like to thank you all of you for showing up, for being with us. Hopefully it was an interesting experience in terms of learning, and I think the most important is about networking with the rest of the community. And for those leaving today, just have a good trip back home, share the wisdom you got with the rest of your team back in the office, and hopefully see you next year, right? Okay.